Well, what do we have here? God, it's getting chilly. It's getting chilly in Pennsylvania. It's a little bit chilly today, and that means static electricity. And so every time I move, there is some kind of a static shock. My computer hates the season because when I get out of my chair, my butt brushes up against the back of the chair, and so it's just a Van de Graaff generator. And so I'll stand up and hear snapping noises in the chair, and then my computer restarts. It's terrible. Absolutely terrible. How are we doing today? My phone just buzzed. Why do we buzz? Why do we buzz, Master Bruce? What do we buzz? Glucose levels a little bit hyperglycemic. I had a burger on a Kaiser roll, so that's going to affect my glucose levels for the remainder of the day. Well, for the remainder of the afternoon until my stomach decides to, it's had enough. Oh, I need to do the Blue Sky post. That's what I need to do. I need to promote. I need to be more promotional and soulless. Post. Are you posting? Motion at the garage. Okay, there we go. Now it's posted. I have spoken. How did I got ketchup on my phone. It makes me feel gross. I went to lock my phone, and there's this crusty stuff there, and I'm like, how did that happen? God, I'm nasty. I'm gross. That's how it makes me feel. Yeah, let's get this thing chooching away. Let's get this thing rolling a signal in there so that we can see something. So I can finally feel something. I don't know how this frequency generator does AC. I guess it makes its own ground or something. Its own offset ground that it puts out to the thing, and then we end up getting pure AC waves out of it. I suppose that's what's going on. All right, let's see here. Are all my chats up? I've got that one up. I've got YouTube up. I've got... Oh, Streamlabs is not happy with me. I really shouldn't be using Streamlabs anymore, but it's a convenience. Let's see here. Silly Russell gift. Haircut and all. I didn't get a haircut. Dude, what's up? Hey, how's everybody doing? How you doing, guys? You guys didn't show up because I don't have a Twitch chat popped out. Let me get that done. Let me get that one done. Twitch TV, oh bother. And then I gotta go over here, and I gotta choose the button, and I gotta go pop out the chat. There we go. You guys should be able to be on screen now again. There they are. Of course, they didn't pop up in the social stream blade, but that should pop up. There we go. Okay, yeah, cool. It's all set up. How's everybody doing? I did not get a haircut. It's just that it's super dry out, and I don't know. I did a once-over washing my hair. I have bedhead hair. Well, not bedhead specifically. It's getting a little longer, so it's starting to kind of organize itself as longer hair. I do need to go to the barber and get this all trimmed up, because this was kind of a bad haircut. They didn't do really good stuff with my hair. My hair just happens to be good at being hair. But I'll have to schedule something soon, because it is getting a little too long, and since it's getting so dry here in the Northeast, my hair hurts. It's like, why does my hair hurt at the end of the day? And I think it's because, well, I've been washing it too often, and so it overproduces oil, and then it gets heavy by the end of the day, and also everything's just so dry. It's bad. But, I'll suffer through. I know I look fantastic, but yeah, nothing has changed. Test 1, 2, 3. There you are, Proteus. Yeah, there we go. Yeah, it's getting a little chilly out here, and so all the moisture is gone from the air. So my hair is behaving a little bit differently than it normally does. But I also got to sleep way too late last night, and yeah, I gotta make good on my stopping of drinking. I gotta stop doing that stuff because it's getting a little too regular. I've got a blood appointment on Monday. So we're just not going to have anything until then, and I'm going to have to deal with what I do late at night, which is, you know, forcing myself to go to bed. I hope you're not having a bad hair day. It is a slightly bad hair day, actually. Here, I got to pull you guys to the other window so that I look you straight in the eye. Yeah, see, this is acting up a little bit over here. The swoosh was a little less organized earlier, but it I guess it's doing okay. It's staying out of my eyes right now, which is all that I can ask. Talking about hair, my beautiful luscious hair. I have blonde hair and I have to wash my hair every single day. Yeah, same. Or else I look like hell. And I find that this is advantageous to having my hair color. The thing about washing your hair every day is that it puts your body into like an overdrive oil production mode. And I wash my hair every day. I just do it once. It's not a major wash. It's just to get it clean, right? And what I should do is every other day I should just skip shampoo. I went to Burning Man in 2011, and I accidentally only brought conditioner with me to clean my hair. And I only used conditioner for all of Burning Man. And at the end of Burning Man, my hair was beautiful. It was like silky smooth. It was insane. But yeah, it's one of those things, like you don't want to go into oil overproduction mode. But yeah, whatever. It's just getting long. That's all. Characteristics of people with blonde hair and light brown blonde mix. I used to have white hair when I was a kid. It would get sun bleached. Characteristic of people with blonde hair. I don't know about that, but yeah, I do wash it every day. Yeah, people are like, why is your hair so great? And I'm like, I don't do anything, and I don't think people with great hair do anything. It's just genetics, which is unfortunate. I have no secrets to share in terms of having amazing hair. What's up, Bothan? So yeah, we've got circuits to play with today. I made some progress on my own. What the heck is going on with this ADR? 80 ohm resistor block has exploded. Yeah, these resistors are getting less and less organized in my I don't know, in my care. And so I don't know what I'm going to do about that. Maybe I can just get a new kit of resistors, but we're going to scrape some resistors out of another kit that I got. We're going to get those 33 kilo ohm resistors out so that we can actually make some of these circuits that are going to sort of decimate the signal and turn it into the 0 to 3 volt signal that it expects. Blonde people produce more oil for their hair. But I think if you take a break from washing your hair daily, it'll make a big difference. Because I've done that before. Although I'm not doing that now, just because it's part of my morning routine. This is a Summerfest 8, which was 7 years ago. These are old mixes, but they're fun. It's good. It kind of fills the background a little bit. Sorry, I double clicked. Fills the background a little bit, gives us a little something to listen to. But yeah, so yesterday I spent quite a bit of time playing with this circuit. And coming up with why it wasn't working. And we'll go over the one sentence explanation. I posted it in the stream project section. It's the positive rail was not connected to this, so it was only operating in the negatives, and that's why we were getting weird results out of it. And once I fixed that, everything is totally and completely predictable out of this thing. I also did some dead reckoning, and I'll explain my reasoning behind what I did. I did some dead reckoning about controlling the potentiometer voltage, about limiting it with resistors and making it into only the voltage swing that we need. Now, one of the things that we've got to consider for this mixer is that there's not space. There's like no room for excess. And so my handling of clipping, signal clipping stuff, I don't really have room for. I could put Zener diodes on it. I gotta have a long think about the chips that I'm using too. The V2164 from Cool Audio is apparently a more rare chip, and that's actually kind of difficult to source, which would make my mixer even worse. Picked up some variety packs of resistors from S1 Amazon made by E. They come in a nice organizer. I should look for that. Yeah, the people were saying to use index cards. If I can find just a blank one of those little miniature folders, I would love to use that. And then I can, put like 2 index card or like, get card stock that's the right size, so I can make little pages to organize all the resistors, and then it'll be easier for me to find them. I just don't like working in through-hole. I don't like it. I would rather do these in surface mount because all the resistors have their values written directly on them. Oh, I forgot to order the surface mount resistors. I've got them in other places though, other sizes. Yeah, it's just one of those things. I just don't like working with through-hole. But we're kind of forced to with this because we're perforated prototyping everything, and then we're gonna move into the realm of the designed circuit board. We're gonna use Fusion 360 for that. But until we get a schematic down, I don't know what I'm putting down. So I guess we do inevitably need through-hole parts. I guess I'll have to do that. Slamazon? It's like Amazon, but they slam you with a package when they deliver the items. Oh, I see what you... Well, that's the Splostal service. The Slam Postal Service. They're the ones that slam your shit down. We tried to order like fancy French mustard, and it came in a ceramic container, and we had to order it like 3 or 4 times before it wouldn't be broken on arrival, because it would get all the way to the people that deliver it, and then the people that deliver it would slam it down on our concrete front door slab and explode it, because the package was only just starting to get wet with mustard juice. So we could tell that it was broken at the end stage instead of any of the other stages. Octaj had the worst time in that vein as well. He was trying to get maple water because he's just that Canadian. He's just that Canadian that he has to get maple water. It's not syrup because it hasn't been reduced. It's just tree water. He's ordering it in these jars. He's ordering a big pallet of jars. And the pallet of jars would make it all the way to his house, where it would then get unceremoniously dumped and they would all explode. And then he would have to contact the seller. I don't know. I don't think he's resolved that situation. I think the resolution of that was to just not get maple water. As a moderator perk, I sent him a bunch of Snyder's pretzel bits because they're made here. And boy howdy, the shipping to Canada is rough. Why does it have to be that rough? I understand we need to go through customs, but there's just these huge fees that are associated with, if you cross that border. It's rough. It is rough. I just don't like sending stuff to Canada anymore. I have a couple Canadian friends, and they're just going to have to live with it. If it were cheaper, I'd have them send me whiskey, because there's a really good Canadian whiskey that I would like to get my hands on. Gibson's Finest. This is the circuit that we're going to work on. Maybe we should look at other stuff today at the beginning. I still don't know what to do, and I know that the neighbor has asked other people in this household whether or not I've messed with this, but the neighbor dumped a Flipper Zero on me, and so now I have a Flipper Zero. What am I going to do with a Flipper Zero? Did it hack into my own diabetes equipment? I think not. This camera is very dramatically moving. We're slow panning downwards. Do we stop? No, we're still moving. Slow pan downwards. Closer and closer we get to the circuit in sort of a disturbing, slow movement that's supposed to foment unease in your audience. They don't know why they feel sort of a foreboding in the shot, but it's because of the slow dolly in. Is that a dolly in? What's the name of that move? There's a name for all these different camera moves. It's dolly in, pan, whatever. Is it done? Is the camera arm done moving? A truck in. Okay, that makes more sense. Here, I'm gonna tighten up the camera stand, and that'll keep it from panning. Yes, sure. But again, I don't know what to do with the Flipper Zero. What do I do with it? Can I program this thing to get me through stoplights? Don't those take a picture of you if you use the override on them? To be somebody in a nearby building with one of these, and so you could just wreak havoc with the automatic traffic light system. You wait until you see the unmarked police car come up and the guy with the little antenna wandering around and looking around to put this thing away and not tell anybody that you've been messing around on the wireless signals. If I still took the train into the city regularly, this thing would be very fun indeed. Maybe. I don't know. And, like, I don't know, I could program it to open my garage, and maybe that's my neighbor's secret plan. Maybe they have a secret plan, and I use the Flipper Zero, and I go, ha ha ha, look at me, I'm opening my own garage. And then I go, well, that was fun, figured out a little bit, you can have this back. And then he enters my garage in the dead of night and borrows my leaf blower. Dun, dun, dun. Yeah, I don't know. I don't know. I don't know what I'm going to do with it. I don't think he's permanently loaned it to me, though, because he's asking about it. So I gotta open up some YouTube videos and maybe learn some heads and tails about the Flipper Zero. I want to find the maximum illegal thing that I can do with this. Like, if I could make it into a murder weapon, maybe? That would be the maximum illegal thing that I could probably do with the Flipper Zeros. Maybe choke somebody with it. But what else can I do? Like, what else would I do? I know their Wi-Fi password now. It's like, I don't care. I don't care about my neighbor's Wi-Fi password. Devious espionage. I don't, like, what am I, decode a Wi-Fi packet? I do not want to know what my neighbors are doing on the internet. And I sure as hell hope they return the favor. I've sniffed this packet from my neighbor, and it appears he's broadcasting to Twitch. Call the police! I'll have to figure it out. I mean, hey, maybe, no, there's no drones in the air around here. Nobody flies drones anymore. Fun fiddly toy. It's got Tamagotchi vibes. The passkey copier didn't work for my office, but it was fun to sniff around the code and see the IR codes being blepped out by different buttons of my remote. You see, that's like most of what everybody does. That they find out, you know what? RF is kind of boring. Like, there's not really that much going on. And, like, if I still worked for the government, I would definitely get in trouble for having one of these, for sniffing wireless signals. But, yeah. Could be an active security breach and potential espionage. What, give me this thing? Nah, it's not like that. I know this neighbor. Yeah, and so it comes with a Wi-Fi kit, too, and it's like, no, I didn't finally get a flipper. This isn't mine. This belongs to my neighbor. He figured that it was gathering dust. I have a really cool neighbor. I mean, he is a bit of an electrical engineer. And so he bought this with the intent of, I don't know, having fun, playing around with it, having a cool thing in his pocket when he's walking the dog. But, I mean, this thing, for the most part, it's like a party trick, right? Like, I don't need to get into my neighbor's garages or cars, although it would be kind of fun to sniff out my car's unlock signal and duplicate it. I don't know what this thing can do in key lock, 2.5 gigahertz space. I'm not sure what it can do. It can probably dominate it, to be honest. And then, like, okay, so what's left? Garage door openers? Sure. Wi-Fi? I don't really care. I don't really care. Everybody has their wireless network here. You know what? The best thing that I could do for Wi-Fi would be to get on their networks and change their channels over to some side channels and spread everybody out so that none of the channels are conflicting. And then all of our Wi-Fis would be more powerful here. Send you a thumb drive. You really need this thumb drive, and it's all storage space. Well, so I was talking to him about it, and I told him that, I tried to buy a Flipper Zero, and my credit card was like, no, that's shady. My favorite use for that is making copies of NPC cards. NPC cards. Can this thing also be a, can this thing, duplicate a, NFC cards. Yeah. So speaking of NFC, the Nintendo Amiibos, because there's big lists of that you can download all the Nintendo Amiibo data. Probably, I'm guessing there's an app on this thing that you could load it up to, and then just do the Amiibo thing so you can cheat at your games. It can. Okay, yeah, that would be a fun thing to do. It's like I'm not cackling like a villain for most of the stuff that this thing can do, you know? The only other thing that I can think of is driving into my nearby town and finding a traffic light that has one of the systems on it that allows the police to overtake it and figuring out what to do. And taking it over, but not from my car. I would not be driving at the time because, oh lordy, do I not want that shitstorm falling on me. It would be very funny and highly illegal to do that, which is why I want to do it. But I would not do it to further myself in any way. I would not be caught dead on whatever camera they probably have on those things, you know, using it in order to get through a stoplight. Could use it as a universal remote to change the channel of TVs at bars. I had a friend that had one of those, the TV Be Gone, and he wanted to boost the signal. He was like, "Bother, I need your help." He's like, I need your help. I want to make this thing powerful as hell. And I was like, all right. He wanted to be able to turn off TVs like from across the street. And we never got into further discussions of that. But what I wanted to do was buy an infrared flashlight and turn over control to the TV Be Gone. All the TVs in demo mode in the waiting room. You could finally turn off all of the motion blur, all of the interpolation that the TVs perform, that for some reason the older generations just simply do not notice. You know, we'll be watching TV, my generation and people who have lived through the switchover in formats and conversions, and we look at the TV and we go, something right about the way these people are moving. They kind of move a little bit too fast in some places. It looks uncanny valley. And you talk to somebody else, like, you know, talk to my parents, talk to anyone, even my brother. You're like, what's wrong with this image going on? And it's like, I don't know, it looks fine. It looks fine to me. No, it does not. It does not look fine. The interpolation is horrible. And all these TVs, I guess that's all they can offer past resolution is interpolation and just messing with the broadcast signal. So it's like all these TVs advertise all this stuff. Look at all these frames. Look at 100 billion frame rates. Our number is bigger than the other number. And that's all they can do because here's the technology. It's a giant fucking screen and it can display stuff at this resolution. It's like, wow, we can't do anything more than that. How do we make our model stand out from the other model? Let's put an FPGA in it. Ba-da-ba-ba-ba-ba-ba. And then they just ruin broadcast television. And it's somehow my generation has this cross to bear where we have to go to the house, go into the settings, turn off all of the interpolation, turn off the weird color correction that's going on, and then you get a broadcast signal. You get what's meant to be viewed. This is basically an argument for my friend's company that he wants to make, which obviously we won't be able to because we can't just make a company out of nowhere. But he wants to make devices that are exactly what's on the tin. You want a phone? Here's just a phone. You want a TV? It's a TV. There's no speakers in it. It's just a TV. It doesn't do anything else. Like, he wants to make products that are just product. It's just the thing. It's not all of these extra whiz-bangs and silly features and bells and whistles that are the thing that you turn off first. Unfortunately, we've seen that in just about every facet of life, in that TVs are now have advertisements on them, and Windows has advertisements on it. It's no longer just an operating system. I mean, it was never just an operating system. Windows was always kind of a couple things more than just an operating system, but now it's even worse. They've got ads and they got tracking, and it is just one of those things where, like, where is that company in life? I guess going to Linux, but I can't use my CAD software in Linux, so. Hell yeah, on the TV Be Gone, I made one out of those. I made one of those back in the day. Easiest way to get a very bright IR is to buy the iRed spotlights, typically sold on security camera lights. Oh, those are those big arrays, though. The thing I have an actual IR flashlight because my my more well-to-do friends like to play around in night vision. And so in order to play around with them in night vision, I got a purely infrared flashlight. Let's see, this one's the UV light. This one's a very powerful ultraviolet light. This is good for curing UV epoxy on the desk. And I gotta top off all these batteries. I don't really feel safe around all these battery operated devices that have all these huge, yeah, this is UV. This one is IR. And I can basically blind people with night vision with this thing. Of course, I don't know when it's turned on. I guess the camera helps us in that sense. The camera has an infrared blocking filter, which is doing its damnedest to keep that infrared out. Because if this got in there, into the camera sensor, without a filter, the notch filter, then all the color coordination would go to hell. It would go crazy. It's looking for a histogram of colors in its viewpoint, which is, again, why I have gray desk mats. But that filter, that infrared notch filter, I guess, it's not a pass filter, it's a notch filter, is really doing its job there, because this thing is bright in night vision. And you can't tell if it's turned on in your pocket. It'll get warm eventually, but mostly you just can't tell that it's actually on. It needs like a status light. I guess that breaks if you're hiding from somebody and you're trying to use infrared to hide from somebody. Having an LED light up on something is probably not a good idea. But yeah, what I was going to do is gut something like this and then put a TV be gone into it. I mean, you could just like microcontrol a TV be gone, and you hit the button, it goes with all the different signals. And if it's blasting infrared at something like that, it'll reach distances. It can only be advertised as a TV if it has coax on it? Who says? Last time I was at the doctor, the TV was still in the demo mode from like being plugged in at the store. Oh, that hurts. Yeah, because then all the color, look at the colors, they're so bright and wonderful. It's meant to be, the TV demo mode is meant to be viewed alongside other TVs. And so they're all fighting for your attention. It's horrible. Making sure. The resistors from the Amazon and the way they're packaged, like, that is fantastic. I really appreciate the piece of information. It's a cool way to store your resistors. Which ones? Are they in like a book? It can only be advertised as TV as a coax. Okay, I think I'm caught up with chat. It's just people are insistent on conversations that I'm not following anymore. I have another pack of resistors, and that's where we're going to get our 33Ks from. We'll get our 33Ks from there, and then we can do the mixing that I want to do today. But yeah, I worked a little bit on the output stage yesterday, and I was able to get everything working again. And so I saved you guys that bit of frustrating troubleshooting where you don't know what's going on, you don't know why something's not happening, and everything kind of goes to hell. Yeah, I'll try to make a little bit of room here. It's a big session of troubleshooting kind of makes a mess of everything around you. Things get kind of out of hand. We'll get there, though. We'll get there. Much progress to be made. This is the same friend that wanted me to mod his Detroit house. In Detroit, there's a particular design that has flying beams in the main family room. And so if you put LED strips on the other side, then you can have a rave house. And so he wanted me to make him a rave house thing. And that was before a lot of these LED systems were super common. They're super common now. You can just like find a system and put it up. There's even Christmas tree lights that let you track where the pixels are and coordinate, make your entire tree look like a candy cane, like an advertised candy cane. I want to get one of those. It's like $100 though. Careful about staring down the barrel of an infrared flashlight. Yeah, I know this. It's good for people to know. You got to watch UV and infrared. Those frequencies are not kind to your retina, especially in the abundance that you can shine them in, because your body doesn't know that there's a lot of light there. We know the visible spectrum, and our pupils contract the visible spectrum. But if you've got heavy UV, like from the blue laser, or heavy infrared, your eyes don't know to contract, and so it all just goes straight in. I was shining this in the camera, and I was viewing through the screen. So. Look up Amazon for E-resistor. I don't know if I want to mess with my search algorithms, but I guess I'll humor chat. Where is my working window? There it is. Oh God, home row error. Home row error. Why am I unable to type? That's clever. So they've got long bins that they're putting everything in. These are probably the 1% super thin, annoying resistors, but that is a clever way to store them. It doesn't look like it'll store a lot, like a lot of different values though. 600 pieces. They just want to make number go up, huh? They just want to make number go up. But like, yeah, I don't know. I don't know if this will be comprehensive. I like the folder idea because then it sits on my shelf in kind of a clever way. If I could get like all of my parts storage to look like that, it's just a bunch of different binders just on the shelf. I think that would be kind of cool. Didn't say they were perfect. No, this is very clever though. Nor do I expect it to be perfect. Different package that I looked up, they're more like a book format. Yeah, that's what I'd like, the book format, because the surface mount sample books are really good at just being a nice storage method for all of your surface mount parts. I would love to get something like this, but then I would put through-hole resistors into it. And I don't mean in the sleeves, because that would definitely puncture. Yesterday I got a puncture wound in my index finger. It still hurts. It still hurts. It's not fair. I got a little puncture wound in my index finger from cutting all the leads on the through-hole resistors and making them breadboard friendly. But yeah, if I could, I need to find just like a little binder like this, and then I can do the taping to index card thing. I think that would be the more cleverlier way to do it. But storing, hundreds of them may be a little bit more difficult. How does this go into a book? I don't know. Where's that other kit of resistors? Let me find that. I think it ended up, oh yeah, there it is. There it is, it's right there. I was so mad when I ordered this. I was so mad because I've been trying to find non-low wattage resistors that actually have thick leads, because solderless breadboard needs to have a little bit of distance to pinch this thing, but these are like syringe thin wires coming out of them, and so they don't really get along with the solderless breadboard very much. They don't like it. I sorted my resistors in a pull-out drawer with 5 to 6 values in each rolled up. The way that we did it, where like if space is not an issue, right? If you're an organization that's doing like electronics shop stuff, and the FBI was, what we had were those big industrial rolling storage drawers, just tons of them. There were like 20 of them in a room, and in the drawer there were bins that faced upwards, right? Upwards opening bins. So if you took the whole rolling cabinet and you went, it would mix everything up. It would be awful. But since they were giant industrial drawers, obviously that wasn't going to happen. In a kit like this, you can't have something open facing upwards without having a door go over it. Otherwise, when you go, they go everywhere. But with the big drawers, you would open them up, and there would be tons of bins. And at the back of the bin, there was taped the DigiKey part number and the value. So it was just the little piece. When you order something from DigiKey, you get all this information about the product, because this is how DigiKey sorts their inventory. And they package their stuff to send to you, and do all those robotic industrial things. You can just cut this piece right here, this top piece that identifies it, and tape that to the back of the bin. And then when you're looking for a particular value of resistor, you go through and you look at the values, and when the bin is empty, you just punch in this number in DigiKey and you order more. So it's a very clever way to do the organization there. They had that kind of down to a T. Of course, then me being the gremlin that I am, I'm a total goblin. When I first started out at that position, I had to spend more than a day, you know, not my whole day, obviously I had work to do, but I had to spend my time going through every single drawer. I went through every drawer. I had to know, in my mind, a relative location of all of the different parts that existed, so that if I ever had to build something, and I did on a couple occasions, I knew where everything was, because I'm a goblin. I'm a total gremlin. I need to have a memory map of this entire place. And since I put together the shop, I have a memory map of this whole place. It must have been so frustrating for the guy that worked there, because a whole bunch of consultants were right next to this shop, and they were always getting their little fingies and all of his stuff. I would have been driven mad by that, because something moves. And if something moves, I'm like, where is something? Why is that not in the spot? But yeah, that's just me. That's just me. You know, I should have tried for that position, because those guys aren't getting any younger. I probably could have taken over one of their positions and then spent my day either working on electronics things that the FBI provides their field agents with ad nauseum, and probably getting sick to death of a design that I had nothing to do with, or replacing batteries, backup batteries. That's mostly what they did there. That was most of what they did there. All this special equipment, all this electronics know-how, and they spent their whole day characterizing batteries and going, yeah, that one's dead. I'm going to put a new one on the charger and see, you know, let's look at the voltage. Okay, let's put it with a diode on the power supply, and let's see if it discharges. And then they'll put the new batteries into the power supply and give it back to the person. So this is all they did. There was, because everybody had one of the battery backups. The building had a generator, but the generator doesn't kick in instantly. So everybody has the battery backups just in case. And so all of the battery backups that were bought all at the same, you know, they come in on a giant drywall pallet, and then they distribute them to everybody. There was a movie, I forget when it was, where they were moving into like a government office, and outside of the desk there was a pallet full of computers, and it's like, can I just get a computer off of that? Oh no, you're not allowed to get a computer off of that. And so they just you know, in the middle of the day they were like, nobody's looking, all right, grab a computer, and nobody noticed. That's what they had. That's what it's like there. There are pallets of equipment sometimes that show up, and so they buy all these batteries on a big pallet, distribute them out to all the offices, and since all of these batteries were manufactured at the same date in the same place, they all went bad at the same time. And so like 50 to 60% of all these batteries had to be replaced in the office, and statistically over time they just kept failing and failing and failing. So it became a permanent job to maintain working batteries in all these power supplies. You walk through the offices and hear beep, 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 and it's like, oh, that's a bad battery. When are they going to fix that? I can't think. All I hear is beep. Yeah, they're all lead acid batteries inside of those things. But yeah, the storage is like, if space is not an issue, the big industrial drawers are really great for having just like bins of parts, even surface mount parts, because when you run out, you look at that thing and you go, oh, it's empty. I was thinking of doing something like that with this, but I don't think going through drawers like that is really in the cards for this stream. Our storage method is slightly different. I use the drawer of stuff. This needs to be organized a little bit more. And I keep these little Quantum Leap looking MFs, these little bins of categories that are organized, which is, I've got too many parts dumps that still need organization. I'll need to spend a little bit of time on that. But these bins are labeled Wentai. They have a little logo on them that says Wentai, but you can just look up SMD storage bins. Really good for SMD parts. Not great for through-hole, but great for SMD. And the classic Husky tackle box little drawer organizer is adequate for through-hole. Anything that doesn't fit gets a big bin or a sewing bin. The sewing bins are nice because you can look into them and you can organize projects with that. But someday soon, I don't know when, and I say that like it's going to happen this year, someday soon there will be a reckoning. I have to go through like everything and just throw out stuff. Like if I have a project that's been disassembled, I need to prioritize reassembling it and putting it back into like a storage form. I have a joystick that I need to put back together too that'll fit on the Thrustmaster setup. But then I need to like gather stuff together, put stuff back, throw out things that I haven't bothered with, and maybe make a bin for things to get to, Like, for instance, the oscilloscope project kit we need to get to that. We need to look at that and see what it is, if it's useful at all. I'm really bad. This show in particular is very bad at striking while the anvil's hot. So if there's some new hot product that all the EE channels are looking at, I'll sometimes look at that and get it, but sometimes I just can't get time to work on it. You know, this stuff we're doing here is real work. We're putting together complicated circuits. We're engineering things. We're designing things in CAD. And like, my time outside of the stream is carrying stuff for old people. I need to, like, prioritize my projects a little bit more and start getting stuff done. What's that? Because like you, I have a mishmash of different sized semi-clear boxes. Yeah, the partitioned semi-clear tackle style boxes, they're nice. You end up gathering them as you order, like, different electronic stuff. You're like, oh, a kit of sensors that I can use for breadboarding. Well, that's going to come in its own little partition bin, and eventually you sort of end of life that bin and turn it into some kind of an alternative storage. The Husky bins that are over there, I bought specifically to store electronics parts. That's what we're doing. You know, at some point we do need to go through, because the clutter is starting to take over. The clutter is taking over, and my propensity to not do anything about my spaces being organized. You can see, just evidenced by my co-host, which is the shop. If you need space on a surface, you just kind of clean it up a little bit. The clutter is enveloping. Yeah, no upward-facing surface goes without something on it. It's like the Zerg creep. We need Vespine gas, is what I'm trying to say. All right, so I'm going to put this aside. I really need to learn something with this so that I can report back to the neighbor. I don't know how these projects just find me. People just find me with these projects, and I'm like, I barely am getting my own stuff done. You know, no is a complete sentence, but at the same time, it's like being open to opportunity is something that it seems like I'm kind of bad at. Because that's how, like, engagement farming and striking the popular thing when it's popular. I'm bad at that. I'm not good at that. Well, anyway, we got work to do, don't we? We got work to do. The entropic asymmetry. There we go. Call it ratchet. It's way easier to take something apart than it is to put back together. Oh, so you're talking about, let's call the entropic asymmetry ratchet. Is that what I'm interpreting correctly? Or are we calling it, or are we referring to the entropic asymmetry ratchet because it's a one-way street? Plastic bin boxes with drawers. Yeah, that would be. I mean, the problem with, like, organizing something like that, it needs to be able to be, like, shaken up, and keep its stuff in the right place. Usually, I used to have a little thing of drawers that was like an organizing thing for, like, breadboarding, and that was a neat little thing. I wonder whatever happened to that. It's probably full of cool electronic stuff. Oh, you know what? I end-of-lifed it for this organizer. This organizer used to have all of my electronic stuff in it. It no longer has electronic stuff. It's just spillover tools. I have the electronics tools here, including scope probes and stuff like that. And then, of course, that and the bin there are holding all of my tools. I got a wrench organizer, specifically a wrench organizer to help organize the stuff that I deposit on the top of the desk. Wire wrapping stuff is over there. Hole punches, for some reason, got there. Those need to go into the drawers. And mechanical stuff is all way to my right. This is other spillover. Screwdrivers are, of course, on the magnet hanger. They're the most grabbed for thing. And then tool spillover, parts, larger parts, smaller parts, old joystick stuff, and peripheral stuff goes up there. It's a mess. It's just a big, active, living mess that I'm constantly trying to maintain. I originally thought I would sometimes see them at garage sales or sometimes on sale somewhere. I would purchase it and stack it up with the rest. Well, the more you do that, I mean, you eventually need to put them into service. That's that like thing in the back of my head that says, hey, stop everything and organize. All right, let's get going. So, my signal is dancing a break dance. That's not much of a break dance. That's a little bit of a break dance. Get the music out of here. Welcome to Thursday. Welcome to Thursday. It's cold here. What's up, Taters Games? It's cold here in the shop. The fan is got a little nip to it. I'm sort of sweating right now, but it's kind of like, ooh, that's cold. It's good. I'm comfortable. I didn't get much sleep, and we're ready to just kind of get into doing stuff with circuits. I'll catch you guys up when I'm done introing. But basically, we're ready to start really messing with op amps in order to get what we want out of the rest of the system. This is a headphone amplifier, but it's for Eurorack systems. We basically have plus minus up to 10 volts in. I'm willing to accept that 12 volts might clip in this system. It might be okay, but I'm willing to accept that it clips if that's going to be the case. Given what we may need to do with the circuit in order to use the headphone amplifier that I want to use, we need to take our signal in from Eurorack, plus minus 10 volts, and boil it all the way down to a headphone signal, which I guess is current-based. It's not necessarily voltage-based, but you're certainly not going to be putting 12 volts into somebody's ears. So that signal we can get on the output with a very simple headphone amplifier. Just a dumb headphone amplifier that doesn't actually have any sort of digital electronics associated with it. Getting rare. All the stuff we're using in this circuit is getting rare, and I don't know what to do about that. The V2164 from Cool Audio is a relatively old chip. So that's sort of the mainstay. That's a voltage-controlled transconductance amplifier. So it actually works in current instead of voltage, and it uses a very tiny voltage in order to control how much it's letting through. Transconductance, I guess, is more useful for filters and stuff. Like, for instance, you have the diode ladder filter where you have a bunch of diodes that your signal goes through, and the more current you allow your signal to have, the more frequencies show up in the other end of that circuit. And so if you have a transconductance amplifier, you can make a voltage-controlled filter out of a diode ladder. It actually becomes simple stuff. It's an interesting little phenomenon. I'm learning more about how this stuff works, and it's getting dangerous. I'm going to start getting the M303 in ways that I was never supposed to, so that I can actually fix the two of them that I have. Anyway, in the meantime, we are working on Julian's mixer, and what Julian wants to do is to use 2 channels of left and right audio and mix them together into one singular headphone output on a tip ring shield jack. So there's 4 mono plugs that go into one stereo plug. And that seems very simple, and it can be very simple. I've decided to take things into the analog realm a little bit, and I've decided to use the V2164 circuit in this application. I think it's okay to do, especially if I need all these volume controls. I need these complicated volume controls where I've got a left and a right channel that are separate that I need to be on the same knob. And then I have a separate left and right channel on the outset that I need to have an independent volume from everything. And so the V2164 allows me to take the voltage of the potentiometer and put it into the control. I did some dead reckoning yesterday, and I did some math. I actually did math. I did math. But I hate numbers so much that I dead reckoned what the resistor values should be in order to keep our voltage swing from the potentiometer between negative 600 millivolts, so negative half a volt about, and positive 3.3 volts, so about 3 volts. And I said 0.5 to 3 is this many volts. What percentage of plus to minus 12 is that total resistance? So if I put a 10K potentiometer and I have a resistor above and below it, the slice that I'm taking from the 10K potentiometer, what percentage of that is it going to be? And it was just this whole weird thing that I was able to actually cook up the ratio, and that gave me something like it gave me like the number 600 or something. And so it's like, okay, so the total is supposed to be around 60 kilo ohms. I don't know how I got that number. I was just playing with numbers. 60 kilo ohms. Okay, what can I do with that? So I need a little bit above, a little bit below. What if I did this value? And I was like, 30 kilo ohms, 30 kilo ohms, 10K, 40 kilo ohms, right? Because, well, actually the other way around, 40, 10, 30. Because we need it to swing up into the positive, but not all the way up, and then only a little bit down into the negative. So I think I got that wrong. I think it's the smaller value on top. And then the whole thing is 70K. That's about 100K, and that's kind of what I've seen in examples. So 70K, and then the 10K in the middle, and I put that together with the near enough as makes no difference resistor values, and I was able to actually, and if we look at the voltage swing here, I'm proud of this because I didn't use numbers. I was able to get the voltage swing. Oh yeah, we turn our circuit on. 0 volts, oh my God. Probably bad for it to give one, well, whatever. Okay, positive and negative 12 running into our circuit. You can see here that the output is a little bit noisy. And I'll show more of that noise in a minute. But our voltage swing from the potentiometer goes, why is this negative? Wait, what? Huh? Why is it going the opposite way of where I think it should go? It doesn't make any sense. Why is it going to negative 3 volts and positive 600 millivolts? Do I need to like turn this one around? Wait, what are we referencing off of? We should be referencing off of the same stuff as everybody else. This is the one that goes the opposite direction. Maybe that probe is... Yeah, see, this one goes, well, okay, we can't, it seems like we can't observe it because of the resistance inside of the chip itself. That's weird. If I take this away, you'll see that this goes from negative something something all the way up to above 2 volts. So this is as close as I can get to a proper signal. I can figure out, I can fine tune the resistors later on, but the dead reckoning got me there. So it was a 30 kilo ohm, 10 kilo ohm, and then a 40 kilo ohm. And that limited us to the appropriate limits. It's just the 30s and the 40s. I don't have exactly those values, so they kind of went a little bit askew of that. What that does is that limits our control so that we know that we're giving it the right voltages. And it seems like the intrinsic properties of the adjustment here of the chip itself affecting my circuit means that I can swing to those voltages, but I'm not going to be able to observe them. Isn't that weird? It's a little weird. But it does work. It does adjust this from kind of quiet to kind of close to, it's a little over full amplitude. So I get from kind of quiet to kind of over amplitude. So once I got that working, I hooked it up to just one of the amplifiers, And the V2164, like I said, it's a bunch of current amplifiers. So they have example circuits in the data sheet, right? And those are usually what we go to. We go to the example circuits in the data sheet so that they can tell us exactly how we're supposed to operate their stuff. So that's what I did. Now I don't have a buffer amplifier on the input because amplifiers are at a premium. Each amplifier that we put into this thing is going to take up a ton of space. This is our total amount of space for this circuit. And we're exploring these op-amp circuits so that we know a lot about, here, let me get this to be the right size. So that we know a lot about our options here. How many amplifiers can we fit? How many amplifiers can we omit? What can we leave in? What can we put in? What can we take out? How much fits on this board? A shocking amount will actually fit on just one PCB. Part of the challenge of making this mixer is to make it work in one circuit board, because that just eases everything up on me. I would like to also do a diode ladder filter on a board like this in this format, because this format is hilarious. It's just absolutely impossible to fit stuff in. Fusion 360 helps me though. It has all these rules in it, all the design rules that you can program in. You can use the defaults, you can program in your own, but the design rules will help limit you from having things accidentally overlap and stuff like that. So what I have here is, because of the design rules, I was trying to fit a TL072, a 2 amplifier chip on the board somewhere. Now, we're going to have a lot of amplifiers, so if I could fit TL074s, that would be nice. I feel like one could fit in between, just right in this area right here. but that's going to be a little bit difficult. Maybe we'll have to put multiple TL072s. But it looks like the total number of amplifiers that I'm going to be able to fit on this thing is very limited. Unless I go to like the SOT 23.5 ones, the little, I don't know, that's too many amplifiers though. We need like 6 to 8 amplifiers on this board just to get the basic functionality out of it. And some circuits, some example circuits that we've seen use amplifiers on like the knobs in order to stabilize things. In fact, the data sheet tells us that it's a good idea to use an amplifier as a buffer because of the resistance of the actual control port, which is again what we were finding right here. Because of the resistance of the control port, if we come in here and observe this, it's we don't see the voltage swing that actually exists there. What is that other line that's moving? What is that? Is that like a math line? Why is there a separate moving line that's orange? Where's my math menu? Hold on, I'm gonna look at the math menu real quick. What are you mathing? You should be off. You are off. It couldn't be the trigger level shifting. There's a red line across the screen. Oh, you know what? It's the measurement. It's this result measurement. I guess I can collapse that and then it'll stay. Okay. Cool, man. What are you? It's measuring the voltage of that trace, and that's why it's moving around like that. It's showing us that it's measuring that voltage there. And then when we turn this up and down, I guess it affects the amplitude of channel 2, which is what's being measured. That's why it's moving up and down. Okay. So anyway, I've got a lot. I've got a lot going on here. Even the robots are mathing. We're all doomed. We are all doomed. But anyway, what I've set up in order to test out these circuits. Now, last time we tried out a bunch of different circuits and they didn't work. Why didn't they work, bother? I'll tell you something. It's because of this guy right here. Always in these projects, you know, it's always this guy right here. What I did yesterday was I hooked this thing up with one wire going to the blue on one side and the other wire going to the blue on the other side. This is it's a quad op amp. So there are, hold on, let me grab this. There are 4 amps in this thing, and it typically requires 12 volts to run, plus and minus 12 volts, 24 volts going into this thing. And what comparators are is basically just a lot of math. They are comparing a positive and a negative lead voltage together, applying it to a huge gain, and then outputting it. And that gain can then be limited by filtering that opposing signal back into itself. And what that does is that damps it out, because these have something like gain in like the hundreds. And so if you send the signal back against itself, it'll damp it out and give you what you're looking for in the voltage range that you're looking for. They are little tiny little mathematicians inside of there. And so each of them is 3 pins. Power pin, 3 pins, 3 pins, power pin, 3 pins. One side of this goes to positive, the other side of this goes to negative. So yesterday, I had this side hooked up to ground. Ground sits between positive and negative. So this thing was operating in the assumed negative space of what is actually 0 to 12 volts. 12 volt potential across this entire chip, which this can operate with. It's just that the math that it was doing wasn't really, doing properly, because that swing was not the full positive to negative 12 volts. So I hooked it up to positive 12 volts, and then I threw a signal into it, and on the outset, we get the proper signal. So the circuit, as of right now, let's see. Yeah, it does not look like what I have in my notes. It does not look like, it does not look like this. Instead, what I have is I have the 30K, 30K, which is actually 40K. I have 40K, 40K, and then an inverting amplifier. I have one inverting amplifier. So actually, it looks a little bit more like this. This upper part. Forget this. It looks like this upper part, where it goes into an inverting amplifier that inverts it and then outputs it. And so I can get a tap of the 2 amplifiers and get our differential signal. So I thought that would solve everything for the TPA612D. This is the headphones amplifier that we're going to be using. It needs a plus minus R and a plus minus L. and then it can go through 2 resistors. Oh God, that's gonna look terrible. 2 resistors and output our signal. And I guess there is a feedback resistor as well for this thing. So that means that we're going to need to control the volume ahead of this thing. And so the schema of our current controlled stuff, our current amplifiers that are voltage controlled, looks kind of like this. So we have our right and our left signals coming in. Those will get coupled to each other with their own normalization and adjustment. Only problem is that normalization only goes in one direction. I can't go above or below, which is where I guess maybe an op amp or some kind of a circuit like that would make sense. I don't know how that's, I don't know about that. I don't know exactly what I'm going to do about that. The positive and negative. I could have one of them go through a resistor and then the other one go through the variable resistor. Maybe that would do it. Turn them into some kind of a voltage divider that you could adjust positively and negatively so that it would adjust one less than the other one. And that would buffer it a little bit. I don't know. But then outside of those channels, I guess we get a little bit more something or other, more granularity of adjustment. I don't really know that this is necessary, doubling these up. The problem is we only need 2 of them. I mean, the other thing would be if I turn these over into some kind of a buffer for their own control. That could be something that I could do, is do the potentiometer stuff into the 2, but then I have 3 potentiometers and 2 extra amplifiers. So that doesn't make any sense either. I'm not going to put 3 of these chips, these $3 chips. This is going to up the price of this thing significantly. My insistence on using this old technology. I think it's going to be a pretty cool mixer when we're done. But yeah, anyway, so then we take the channels into left and right mixed. And from there, we then put them to transconductance amplifiers. So what these are doing is just turning the amps that are flowing through here into volts, and that gives us our output voltages. We turn volts to amps up here, and then we turn amps to volts back over here. It's a lot. It's a lot. I kind of came up with the circuit last stream, and I've been refining the output here because, again, we're taking baby steps through this thing. I need to know what my output looks like, and I need to get my output into the right range. Now, Eurorack is plus minus, what, 5 volts, plus minus 10 volts, plus minus 8 volts. I've seen references to 8 volts from Mutable Instruments. But Mutable Instruments might not be doing what whatever other module Julian has is doing. We just have a wealth of knowledge of Mutable Instruments. Let's find something in Mutable Instruments that either inputs or outputs audio. I want to take a look at that and figure out what the voltage ranges are there. And then we need to look up that headphone amplifier. I bought 10 of those headphone amplifiers. I'm going to have quite a few of them. I think it's a good bet, though, because, I mean, look at this. They just put a picture of a headphone there. So I will be able to give it the left in and left out, right in, right out, and give it a little 1K feedback and give it a 39.5 ohm resistor, and that's that. We're done. Let's see what our LR in and out is. So what does pin 5, 4, 16, and 17 actually, what is it actually capable of? So shows a complete circuit schematic for such a system. Digital audio is fed into a high-performance stack. The PCM 1972 is a Burr Brown product. We read about this last time, and I don't know how much information we gleaned from it. I've been getting better and better with this stuff. I'm starting to really kind of learn my way around analog circuits. It's having dealt with RF, this stuff is a little bit familiar. Oh yeah, and then the other thing I discovered yesterday, by the way, what you can see on the scope is a sweeping frequency, and then when we observe my 2 different outputs, from the 2 different amplifiers, I have gotten it to be a differential signal, but something is up. Something is awry. What's going on here? Hold on a second. Let's enhance. Why is there noise on the line? Look at all that noise. Where is that noise coming from? I tried switching the amplifier to AB mode, and that did nothing with the noise. There is just this intrinsic inherent noise on the line. But the cool thing is, that frequency sweep is like a limited hearing range kind of thing. It's not a full sweep. The full sweep takes too long. This is a limited sweep of frequencies that are in the audio range. Frequencies in the audio range, look how big they are compared to that noise. And is the noise common mode? Doesn't really look like it. No, it looks like the noise is opposite of itself. It's like a ringing that's occurring. And it might be, I don't know, some transistors somewhere being little bastards. So what we have not included in this circuit is, well, it's visible in all of the data sheets for these things. It's this 100 picofarad capacitor. Now, I had 120 picofarad. That was the only thing I had. So if we include a 120 picofarad capacitor, what we can do, where's my tweezers? So I had troubles finding all these things in through hole, so I did a little resistor adapter. What I can do is just drop that filter in. Almost breaking the chip. I think I did break the chip a little bit. That might have actually done damage. No, it looks like it's okay. And what that does is that significantly filtered out the noise. So if we put one of those on all of the amplifiers, we might get a much less noisy system. In addition to the fact that I believe that headphone amplifier is going to do a little bit against the noise as well. But you can see that like has a huge effect. Without this thing, it's like you get all this ringing and high frequency nonsense. So we just drop a cap, and what happens is at those frequencies, the capacitor gets the high frequencies kind of get by the capacitor, and they cause it to damp those frequencies a little bit more. It's just a weird effect of what sort of the capacitor in the feedback of an op amp does. So yeah, I'll have to pay attention to that in the future and make sure that we're not getting a ton of noise. Okay, so that being said, we should take a look at this amplifier and try to make, we're looking at the output of this whole system, right? Because that's the easiest place to start, right? Is how do I have a chip coming in the mail, how do I make the signal for that chip? I need to resolve that first. Then I can get around all of the weird filtering that's going on. So all of the weird routing that's going on. So we're starting at the end and working our way back now that we've got an example from the data sheet that works. And I've got a differential signal, but I kind of need to revise the way that that's being done. But we'll do that, and we'll adjust the output to be in the appropriate range at the same time. Now, this mixer is in a Eurorack system, but we are outputting to something that's not a Eurorack. And that's where this chip kind of comes into its own. It's not specifically for Eurorack. This is just to drive any old headphone. But it does operate in a plus-minus 12 supply, which is good for us. That means we don't have to do a lot of filtering. The only problem is the stuff that I'm introing and we might need to use in order to limit the amount of current that gets to this chip. They might introduce something that we need a 3-volt supply for. I might have to put an MCP 6004 on that final stage of amplification, in which case I will need to put a, I'll need to put like a 10-volt supply and then a 10 to 3. Okay, all right, hold on. I got to think about this a little bit. Let's figure out what our limitations are, though. Do not place a capacitor on the feedback path. Doing so can cause oscillations. Okay, so for this one, you're not supposed to, but okay, let's see here. We can look at the properties, right? Rn minus, Rn plus, those are the pins. Differential input voltage is 6 volts. Input voltage for VI plus minus VCC. Supply voltage where X is equal to L or R channel. What? Minimum load impedance, operating temperature, etc. So load impedance 8 ohms. So 6 volts. Are they talking plus minus 6? Differential input voltage VID 6 volts. You'll need some caps bypassing on the supply. Yeah, I'll have to build those in later. But like this is saying that's 6 volts. I thought it was 0 to 3 volts. We'd have to do the offsetting and stuff like that, which means we'll have to introduce a voltage reference chip. Single ender differential, independent power supplies for low crosstalk. Output enables amplifier to respond quickly, blah, blah, blah. AB amplifier. So there's 2 packages. One of the advantages is that this thing comes in quad flat, no lead. So I'm actually going to be able to fit this on the board and have a little bit of room to continue my design. But what I want is what is our maximum volume into the thing? And then we'll have to see what audio signals in Eurorack. I guess our maximum volume should be somewhere around 12. We want to be able to amplify as well as just attenuate, though. All this stuff will need adjusting. We'll have to figure out what the topology of the whole thing is. The topology of the whole thing is on the outset. So let's go back to the example circuit. I mean, I guess there's these two. Total harmonic distortion, harmonic distortion, harmonic distortion, harmonic distortion. Characteristics, power dissipation versus total output, power versus output power, supply voltage rejection, crosstalk, power dissipation versus power output on the 50 milliwatt scale. PD, power distribution of watts. No. So let me see here. That's the, look at how complicated it is. Current feedback results in a low voltage, current feedback amplifier. Low distortion, high loop gain throughout large frequency rate and can be used in similar fashion to voltage feedback amplifiers. Low distortion, TPA 20, signal noise ratio of 128 dB. Because the power supplies for the 2 amplifiers are separately, one amplifier can be turned off to conserve power. Well, we're not doing that. We're not conserving any power. So digital to analog. So that's one example. And on the amplifiers that they've got going into it, these are on current. They're turning current into voltage. These are transconductance amplifier mode, and it goes directly into this chip. This thing is powered off of, it looks like 5 volt to ground. Is that the signal that would be expected coming into this unity gain voltage amplifier? Is that going to be, these are both referenced off of 5 volts, huh? We got a 3v3 coming in here to the digital ground. So the digital's at 3.3, and then the VCC 2L and 2R are at 5 volts in ground. Maybe that's what we're supposed to be doing. Use to convert the current to an output voltage. The OPA 4134 is a low noise, high speed, high performance operation amplifier. Let's take a look at it. OPA 134, high performance sound plus audio operation. The acronym is AOO. Let's see, AOA. Look at that. It's an amplifier. What's my plus minus on this thing? 36 volts, -5 to +5. So this is at what, ground to 36 volts. What are they saying around here? Maybe they got a little bit of information about what voltage this thing is taking in. VS plus, V out, RF, nothing. No specific voltages. It's just a generic. It's TLS74 is fine. Back all the way to the page that we were reading. CF and RF are used to set the cutoff frequency of the filter. The RC combination in figure 13 is a cutoff frequency of almost 60 kilohertz. All 4 amplifiers of the OPA 4134 are used, so the TPA blah, 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 can be driven differentially. The output of the OPA 4134 goes to the TPA blah, blah, blah. The TPA blah, blah, blah is configured for use with differential inputs, stereo, and a gain of 2 volts per volt. That's a lot of volt for your volt. So 2V per V. Note that the 0.1 UF caps are placed at every supply pin, as well as the 39 cents output. Weird, that's a weird one. Each output goes into the channel pair of stereo headphones where the listener enjoys crisp, virtually blah, blah, blah. The most basic configuration, 4 resistors must be turned. Yeah, but what about like the input to the thing? What about my input? They always do this to me. They always calculate everything in gains, and I am responsible for running the maximum number from the front to the back of this thing in order to make sure that my voltages are in the right places. I don't know. Maybe I should reconfigure the way I think about these things and actually think about like what gains are and do all of the matching of impedance and stuff. I remember going through that in one class and I said, this is really easy. And then my brain immediately jettisoned all of that knowledge after the test. I was like, wow, that's what they're doing when they're impedance matching everything. And it's like, I forget all that now. Series output resistor should be between 10 and 100. The output series resistance eases the work of the output power stage by increasing the load when low impedance headphones are connected, as well as isolating any capacitance of the following traces. Blah, blah, blah. Current feedback amplifier, take care when choosing the feedback resistor. TI recommends a low level, blah, 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 blah. The value of the feedback resistor should be chosen by figure 17 as a guideline. The gain can then be set by adjusting the input resistor. The smaller the feedback resistor, the less noise is introduced into the system. Well, unfortunately, you know, we can't do variable gain through the knob. We have to do it by a voltage level. And maybe we could even not linearize, do it as a logarithmic scale with some light modifications of the circuit. Smaller values move the dominant pole to higher frequencies, making the device more susceptible to oscillations. Higher feedback resistor values also add more blah, 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 blah. 10K ohm, 10K ohm. Typical application, capacitance at the output can cause oscillations. Capacitance from some sources, such as layout. So that's it. If you have two traces that are next to each other, there's going to be an inherent capacitance to them. That may cause ringing of some kind. I don't think we're really going to have to worry about that very much, but it is something that like should probably be in the back of our heads. It's just we're going to be designing stuff in such a space-constricted area, and I'm going to try to have good ground planes on this device. I mean, unless we run into a specific problem with it, I'm not going to be too crazy about, like, these two traces are next to each other. They're going to cause interference. The series resistor RS should be, I'm worried about not blowing up this device. Man, you guys throw me something here. Differential inputs are useful because they take the greatest advantage of the high SMR of the device. The two feedback resistor values must be kept the same, as do the input resistor values. Well, that's all good. So, I mean, it's a non-inverting gain of 2 volt per volt. That's non-inverting. This is it's also a non-inverting. So if we give it an uninverted signal, we need to give it an uninverted signal in the end. Both amplifiers are powered on. Only one channel is to be used. No, we don't need to worry about that. Follow to prevent unused amplifier from oscillating. Okay, this is a lot of frequency stuff. Oh, a network analyzer. Let me just get my network analyzer out of my network analyzer pocket. A network analyzer can be used to determine the inherent stability of the system. You don't say. That sounds like a really great thing that you can do. You can just use a network analyzer on it. Do I look like I have network analyzer money? Those things are like $60,000, aren't they? Maybe there's some cheaper efforts, but nobody's really going out and saying, I'm going to do a DIY network analyzer. Let's go to Amazon and see if we can just find like a network analyzer. God, why can't I type on this keyboard anymore? Let's just, hey, why not network analyzer? Yeah, let's just look up one of those and just, okay, so there are cheap ones, but I mean, $119. This one's $60. $80, $50, $8,999, and that is just because Rygal has positioned themselves in being just a little bit above the hobby gamer's ability and budget. These are nice pieces of equipment. Your network analyzer 10 years ago would cost you $60,000. So that is an incredible deal for the home gamer. If I was the kind of hobbyist that had $9,000 burning a hole in my pocket, I'd probably buy a car. But I mean, anyway, if you really wanted to network analyze, you could get your network analyzing done 1,000% off. That would still be $800. That's what I spent on this scope. I don't know how much I trust the $319 network analyzer. It's probably pretty good, though. They're probably pretty good. But, I mean, definitely the $400 TV remote. Network tester with Wi-Fi and distance to cable fault indication. Only $400. Yeah, so a network analyzer is like a hardcore piece of equipment, for frequency analysis, right? It does some pretty crazy stuff, and it probably does SWR and all that fun garbage that I would want something like this to do. Look at that thing. But yeah, the companies always assume that you've got like the best stuff. I don't even know what that means. Yeah, I kind of do actually. Cool, yeah, let me just go get my network analyzer. I guess I could have a network analyzer pocket. Those things were small enough to put in your pocket. The world is changing. The world of these tools is changing. But typically with test equipment, if you've got a piece of desktop equipment called a network analyzer, you're not allowed to touch that because that's an expensive thing. Yeah, current feedback amplifier, and they go into all the amplifier stuff. But what I'm trying to determine is what is maximum volume, because that's what I want my signal to be in my test setup at the end. I am adjusting volume in 2 locations, and I want to know what my bumps up against the rails volume is, where things distort. Where does it start to distort in terms of voltages? Is it plus and minus 6? It says it's up to 6 volts. And with the 2 volt per volt amplifying, that would bring it down to 3. If the VID 6 volts and 8 ohms of impedance, when the TPA is powered down, TPA incorporates an exposed power pad on the underside of the chip. This acts as a heat sink. Okay, so that's the level listed above in passing ASNI, SDA, JDEC. Okay, that's just what happens when static electricity hits the thing, and or you put it inside of an electrical cabinet. Supply voltages 5, 15, single supply 10 to 30. We're going to be plus minus 12. That's just inherent of Eurorack. And that means that we don't need voltage converters. We may need voltage converters if I need to limit the amount of volts that this thing can take. If somebody gives our device a plus minus 12 volt, and our TL074 is given plus minus 12 volts, and it's going to pass plus minus a bunch of volts through another op amp that doesn't limit anything, so we'll either need to incorporate Zener diodes or limit it inherently within the voltage of the op amp, then it's possible that we can get a signal that will damage this chip. This chip is not Eurorack. It's just an older, more universal, headphone amplifier. Can we find like an example? Let's find another example. TPA 6120, TPA 6120 circuit. Maybe we can find another example that's going to just kind of open this up for us a little bit. Many of us experimenting with many different power amplifiers run into the problem of needing a preamp for tests that can handle all power amplifiers concerning input level and impedance. This guy speaks to me. This person, rather, this fake French person. Low price and nevertheless minimum THD. What was that again? THD was like a through-hole discussion. Yeah, it's something to do with noise. Total harmonic distortion. There we go. That came to me in a dream. I noticed low-cost headphone amplifier board based on the chip has a THD that reaches below 0.001. That's a fake number. And can handle low impedances with high output level. Evidently, the board can also be used with headphones. All of the data sheet shows a pair of headphones on the output from this chip. You think, buddy? I'm trying to find the... every single one of them has just the cat with headphones on it at the end. They always show headphones at the end. So yes, of course it's... Okay, anyway. Amplifier pair include TP, blah, blah, blah. Power supply functions without concerns. The amplifier works, but with one rather important drawback. DC offset at the output. Chip is configured as a non-inverting amplifier and is recommended by TI with low impedance resistors on the feedback path. TI recommends similar low impedance for the non-inverting input, but, big but, this board is aiming at high input impedance through the use of 50 kilo ohm volume potentiometer at the non-inverting input. What? Wait a minute, what? Oh, it's the board that they got. That's what they're doing for volume control. That's kind of bad because it can get scratchy and stuff. That's where those transconductance amplifiers come in handy. I've got sort of an obfuscation of the voltage level coming through. It does mean that when the device heats up, it might get a different resistance, and it might affect the voltage, and maybe it'll have some weird things, but I think maybe in our application it'll be okay. Very different impedance levels seen from the two inputs easily end up in important DC offset output. Blah, blah, blah. The board was supplied as a kit. I never used the 50 kilo ohm potentiometer, but settled for a less demanding 50 kilo ohm potentiometer. I never used the 50 kilo ohm potentiometer, but settled for a less demanding 5 kilo ohm potentiometer. There we go. It's all in the little details, right? Even with 50 kilo ohm, the DC offset of the output exceeded 50 millivolts. With 50 kilo ohms, DC offset will be considerably worse. No miracles in the amplifier part. Oh, come on. I thought it was going to be a good chip to use. Schematics below. The upper circuit is power supply. The middle circuit's the amplifier. The chip needs low impedance input circuit as shown by TI. Again, not talking about where things start to distort. What voltages, man? Pretty mandatory. I made such an input buffer using an OPA 2134 in non-inverting coupling with gain of 2. The 50 kilo ohm potentiometer turned to max. The DC offset of TPA 6120 output is around 2 millivolts. A pity the board does not include such a buffer circuit. The board can be used as a preamp without the buffering stage, blah, blah, blah. With the modifications I made, the board sounds great. Both are at preamp for linear. Okay, so let's take a look. What is you doing here? There's the OPA 2134. There's the TPAs, and those are going to the output. And they've got just this 50K stereo potentiometer. That's what I wanted to avoid in this thing. I don't want to have to use a potentiometer in my audio pathway because I know who's using this equipment, and I know they're not going to take care of that potentiometer. That potentiometer is going to be under the utmost of terrible conditions. This thing right here, this is the damage point of the rest of the circuit. This thing is going to get thrown down a flight of stairs. And so when that potentiometer inevitably gets wriggled into its worst state, I don't want to have scratches that can be heard. Now, it's going to be an Alps potentiometer, so it'll be a nice one. But like, I don't want that to affect the rest of my circuit. So we're going to put it behind a layer of obfuscation and use the current amplifiers in this thing instead. It'll just have a voltage level that it outputs due to the resistors going into it. We'll have to see what happens when I plug it into multiple units to control them simultaneously. This may be something that we need an op amp for, which I'm not excited about because it's three knobs and that's an uneven number of op amps. So we might have like leftover op amps. I don't know. So yeah, the 2134s, they've got an input going into it, and I don't know what voltage what the voltage limit of that input is. Because we're turning it back into voltage, I want to know what my audio level limit is, and I'm not finding that information anywhere. It's something that I guess you can calculate from all the stuff that they give you, but I would rather it said, you know, right straight away, what are you feeding this thing? What are you feeding it? I got 2K and 10R, 47 going through a 50K volume knob. You got 100 kilo ohm to ground. It's a very weak pull down. That's just for if, I guess, the line floats, maybe? That's some kind of a filter, though. Wait, what's input there? OPA, and then, because if this is for like line level, right? Headphone amps make fine preamps. I like how they can drive low impedance loads. Bought the kit here. Apart from DC offset, I have no complaints. Great price for a fully built HPA. Needs only trafo. What the fuck? Okay. Extremely good amplifier. That's nice. That's nice to hear. 2x6 volt acid cell. Oh, so we've got a freak. I got some kind of a freak. I use it in my underground bunker. So I see 8 fantastic specs with even less total harmonic distortion. I had to try them out. My only concern with this headphone amplifiers is the cooling with low impedance headphones. Oh, that's weird. I guess we'll have to pay attention to our ground planes then and make sure that we cool it properly. I don't think we're going to use, you know, low impedance headphones, but I'm not sure. Nice sounding current feedback op amp is noted by my after looking at the Snare Tech board, properly designed, Board will almost always use SMD around a very fast op amp like the TPA 6120. In addition, nobody in the right mind would connect some cheap and or not so cheap volume pot connected directly to its non-inverting inputs. That's what I was saying. Yeah, I agree. I agree. Rustling leaves syndrome. That's the shh that you hear when you adjust the volume. That's a volume knob that's directly in the audio path. I would very much like to avoid that. And any pops and clicks when you plug in, and this apparently deals with that. I just wish I knew what my limits were, because I'm trying to figure out what the design of the final stage is going to be in our circuit. In our circuit, we are outputting to headphones, but we're all in this browser. We're outputting to headphones, but we're coming in from Eurorack. So we've got an input signal all the way over here that can be plus minus up to 12 volt. But typically it's 10. For Eurorack audio, right? Or is it plus minus 5? Plus minus 5 is like control voltages. Eurorack audio voltage. Oh, hold on. Wait for it to dox me for clicking on the page. Yeah, hurry up. Come on. All these time delay things in the Reddit design. The new design. I like the old Hey Reddit and stuff. Control voltages plus, okay, I'm starting to look at building some of my own Eurorack modules. Me too. But I'm finding it hard to get a definitive answer on what the voltages should be. Everybody is sort of feeling around in the dark. That's what I really hate about Eurorack, is that there is no set in stone standards. And so you design for the most extremes. I know it varies between manufacturers, but what's the best to make my own? So they assume CV plus minus 8, pitch CV, 1 volt per octave, 0 volts to C3, gate and trigger 0 to 5. People do 0 to 8 for that. Audio plus minus 10 volts. And I think that's what Mutable Instruments designs for. So I am of a mind that I should be designing for plus minus 10 volts. If I send 10 volts into this headphone amplifier, is it going to explode? What's going to happen? My frequency generator can only go to plus minus 5. So we can't test at those voltages unless I get DC. Only standards are powers plus minus 12 and 5. Signals should be 10 volt peak to peak. This applies to CV and audio, although it can vary a little bit in amplitude, and there's some disagreement about whether CV should be 0 to 10 or plus minus 5. This is what I'm talking about. That's like a huge range of stuff to plan for. Hi-yi-yi. Hi-ya. Is anybody following with me today? Does anybody even remotely know what I'm talking about? It's okay to be completely lost. I am. So if we have basically what he just said in that comment is that CV can either be 0 to 10 volts, audio can be plus and minus 10 volts, CV's typically plus 5 to minus 5, which is a 10 volt spread around ground. Build a vacuum tube PC to warm the workplace. I might have to. Not the math. We do everything by trial and error. Yes. Yeah, over-under voltage protection at the inputs. Using microcontrollers or ICs beyond range. So I have to figure out whether or not this headphone amplifier would survive me blasting 10 volts into it. It probably can't. Spoilers. So I am going to need some kind of an amplifier structure that's going to attenuate a maximum value of plus minus 10 volts down to the maximum volume of this chip. That way, if you blast it completely, and you know, either I do that or I limit it to plus minus 5 volts, and I put Zener diodes in there to clip it at those voltage levels. And so that'll clip at plus minus 10 volts. But then Julian will probably plug something plus minus 10 volts into it, although I haven't observed any of his audio signals. I don't know what exactly his signals are. But when he plugs something into it, he'll go, it clips no matter what. I hate this thing. How do I deal with this? I make it plus minus 10 volts maximum. I make it capable of going all the way to 12 volts, and then the volume knob needs to be centered somewhere around that, so that we are attenuating, and then, or we keep it, no, they're all at max because they're mixing together. So I can turn them all up to 10 volts, and then the output's going to be 10 volts, and then at the very end stage, I take that output and I smash it down into 0 to whatever doesn't blow up this thing. And maybe that's where I put the diodes, because all of this, all the cool audio stuff, the actual the whatever it is, the amplifier that I'm using in order to do the complex routing and the mixing, this thing right here can survive all of those Eurorack voltages. I mean, we are converting the voltage into a current here. I got to figure out how this math works, how the 30K, is it measuring it across the 30K? I'm not exactly sure what's going on right here. And there's also the possibility of replacing that with a buffer amplifier. Although, to be honest, I think I need a buffer amplifier on the voltage control, because setting something to a voltage is more of a op-amp job. Although it does work with one single thing, so maybe we should test that right now. I want to get down to the nitty-gritty on this thing. I want to actually start working with it and figuring out what those are. We kind of got pigeonholed into research, trying to figure out what we're giving this TPA blah 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 blah. So the TPA blah blah blah, I need to figure out what the max volume of it is. And it may require a little bit more reading or just interpreting what the datasheet's telling us. A real engineer would come up to me and go, "You're an idiot," and point out where exactly it tells me what. They'd say, "Look at this gain over here. That definitely means something else." Sure you don't need more resistors? I actually don't have the 33 kilo ohms. I don't have them. I ran out. So yes, I do need more resistors. I ordered 100. And then I realized that I had this other box of resistors underneath. This other box of resistors will have the 33 kilo ohms that we can use. So we've got all the parts that we need for now, except for this thing. I could hook up a pair of headphones. I have high quality headphones that aren't $500 that I can plug into this thing and test with, and we can figure out where it starts to clip. But I don't want to just do that. I don't want to do this task by feeling it out. Everything else we can do by running into the the bumpers in bumper pool. So it's like the gain is 1 volt per volt for a 16 ohm load, or rather 2 volt per volt. Signal noise ratio of 128 dB and a total harmonic distortion of 112.5 dB. I don't know what that means. I don't know what that means. Maybe that's my problem. Up to 128 decibels of dynamic range, but that somehow 128 dB in volt. That's not going to do anything. Decibels to volts. I don't trust you, AI. Get the hell out of here. Oh, it's 25.1 volts. Yeah, okay. Oh my God, Exatron. Are you running off of a Raspberry Pi? Do you need help? Do I need to like get a shovel and start moving the data back and forth? Oh, you're not in good shape. Okay, we'll leave you alone to rest in peace. Yeah, it's not dBV, it's dB, so we would need dBV in RMS in order to convert it back and forth. Let's see, what they probably give me the information, they're not explicit about it. Max output swing should be the max output wattage RMS converted to VPP. I don't know if I want to show you guys my VPP. It's VPP. Let's see here. So you're saying max output swing should be the wattage between the wattage RMS converted to VPP. Are we given that information? What is the information? What $500 headphones do I have? The Paradynamics DT1990s. There we go. Sorry, it took me a minute to get there. I have some less than $500 headphones. I have some B&O headphones that I could put on it for sort of the 300 ohm pair of headphone test. But I don't want to blow up my headphones. They're still not cheap. I also have a shitty set of earbuds that I could plug. Well, actually, I have a nice set of Shure earbuds that are really nice, actually. Bought them a long time ago. And I thought, man, these are expensive earbuds that I'm buying. And it turns out that I've used them for 10 years, and they've been amazing. Been rocking the 1770 Pros. My only problem with the DTs is that they're these huge, you look like a Mega Man character when you put them on. And it's like flaunting money in front of people. I'm not big into that. When we do game streams, I'll have those things on, and they look like I have like Frankenstein bolts on the side of my head. I'm considering, I got the Shure earbuds out of storage, so maybe I could use those, because those have the foam. I had to buy new foam for them because they're so old. But they are really good. They have really good response, and they've got deep audio out of an earbud. I really like them a lot. Those are Shure EC7s, I think, is what the earbuds that I have are. So, I mean, I could plug them into this circuit, but God help me if I break any of the headphones that I like. So, I really want to be careful about this. What the hell is going on with the you know, they never give you the voltage information, and I'm thinking in volts because our audio is coming in as current, and current is wacky doodle imaginary space for me. I don't know much about manipulating current. And then it goes into something that turns it back into voltages, where it goes into this amplifier that's going to do all the math for me. So I don't have to worry about, you know, specifics in that sense. I want to be able to give this thing maximum volume audio at 10 volts, 12 volts. Start with an equivalent high wattage resistor. I mean, yeah, we could do that for sure. Supply voltage, load impedance, operating free air temperature. 85. Okay. Input offset voltage measured differentially. Typical 2, maximum is 5 millivolts. Input offset voltage? So we need an offset voltage of 5 volts. VO in electrical characteristics. Output voltage swing? Output current. I'm looking for the input voltage. Output voltage swing, VCC plus minus 15 volts with R load at 25 ohms. But that's not... So this is the chip that's going to do all the work for me in terms of getting it to be the output voltage. Depends on the gain the chip has. So if we're 2V per V, and we're at plus minus 12 volts VCC, what is our input swing supposed to be? What's our input? VCC plus minus 15, RL 25. It's 11 to 12, 12 and a half to 22, 12 and a half to 12.2 on the output. So that means that at 12 volts, I mean, they've got it in their example circuit. If I could just decode their example circuit as our limitations, then we can determine what my specific circuit should be. But I just don't know much about the PCM 1792. That's part of decoding their example. Their example is whatever's coming out of where are we? Whatever's coming out of the PCM 1792 is going into a transconductance amplifier with 1 kilo ohm resistor in this DC. No, it's V minus to V plus. Why is V minus at the top? What is going on there? Why did you guys do this? And then it comes out into this thing, and then it gets an amplifier. This thing is set to a 2 volt per volt gain, is what they said in the documentation. But then it's like a direct. It just goes directly into it. Build and feed it with a functional gain and characterize. Yeah, I don't have the chip. I don't have the chip yet. It's coming in the mail. So 2 volt out per volt input. And if the output says plus minus 11, then the input is in the 11 over 2 range. So that would plus minus 5. In which case, the scheme of having the op amp limit it, you're just guessing what it is. I think it sounds right, right? sounds right. And I guess we can design for it, and then I can mess with it later on. I don't think you're supposed to put 15 volts into a pair of headphones. I don't know. The TI would know better than I would. That's a good emote. I like that one. It seems like putting 12 volts into somebody's face is not really a recommended thing, but headphones be doing weird stuff, I suppose. If the headphones are 600 ohms. Yeah, God. This bugs me. I just want to know what my maximum value is, and I guess we can come in here and mess with it on the bench to figure out what's going on. This thing does 5 volt output, 5 volt analog. So it's DC, 9 volt RMS mono, 4.5 volt RMS stereo, 2 volt RMS stereo. I see they give it to you in parentheses after they give you the, yeah. I have a friend with a pair of AKGs. Those are nice headphones. I was considering buying them until the Baradynamics went on like super duper sale at some random audio place. And my friend was like, you have to buy this now. And I'm like, I don't have the money for this. He forced me to buy it. And then we had a pandemic, and I got a $600 check from Donald Trump. And I said, what am I going to do with this? Well, what does he do? He bloviates, and he makes a lot of horrible audio that I have to listen to. So I bought a headphone preamp and a DAC with the money. And it's a tube DAC so that you get less harsh audio out of that bloviating, sycophantic, bloated garbage. All right, anyway, he signed the check because he's so fucking anyway. All right, no, not doing it. Let's get back to work here. I only got one of those checks though. I didn't get the two. I didn't have a job at the time. I was just hanging out, and it's like ding. I'm like, what was that noise? Oh, look, a check. I'm glad I got the audio stuff though, because the boy howdy is that good audio coming out of that thing. I have spent many evenings pegging the volume knob. What's wrong with you people? Well, nothing, but I just don't think about me like that. I've spent many evenings maxing the volume knob, we'll call it that, and it's kind of amazing what tubes do to audio like that through good headphones. It does not feel harsh. It feels like you are just getting closer to the source. So it appears that this thing is outputting something like 5 volts. And it appears that voltages in audio are just kind of wibbly wobbly, and we just kind of make it up as we go. Does anybody know what they're talking about when it comes to this stuff? The answer may shock you. It's no. So let's get to actually just like looking at waves and doing cool stuff, because we've been running this frequency sweep for a little while, and we got rid of noise with a capacitor on the output, but we're going to assume, I guess, a 1-to-3 ratio on the output. That's kind of what I thought of previously. If we're outputting up to 10 volts, we take a third of that and we're at 3 volts. If we offset it, then we're 0 to 6 volts. We may need a 3 volt offset on this thing in order to, do we have to DCize our waves? And sort of that's where we are in the beginning here anyway. But what this actually represents on the scope is not what you would think. The scope is the output from my op amps. Where's the thermals? Given a 3 volt, or no, I think it's a 5 volt peak to peak. What are we doing right now? We're doing a sine sweep. Yeah, it's a 3 volt peak to peak signal. So really on the very output that we give to the headphone amp, that should be, actually that is in spec, but if we were giving it 10 volts, so that should be actually be a 1 volt peak to peak signal. No to what? No to what? Because it's a dual supply. What? I don't have to offset it. But they're saying 6 volts in the data sheet. No needing a DC. That helps because I don't have to make a reference voltage level in order to perform the offset. Sorry, even if with like a 1 second delay, I really appreciate like working with you guys on this stuff because you guys are way smarter than I And I love interacting with my audience. If you are laconic and trying to get something across to me, it's very frustrating because the delay is going to make it so that I've already moved on mentally, and I don't remember where I came from because I'm being animated and emotive, which is not my natural state. It's not my natural state. I have to do this for streaming. My cleverness and my wordsmithing is always a constant, but I'm a little bit more introverted. So when I stream, I have to act a fool, and it scares my dog. It's why Willow won't come down here and sleep under the desk like she used to. She doesn't like me yelling at the furniture. I'm an EE and somewhat bored with what I should be doing. Welcome to my entire career at a regular job. I got, so you know by the bio below, I used to reverse engineer terrorist electronics, which include bombs. And that was really cool at first because it was kind of like an academic setup and you could walk around and talk to your coworkers and there would always be something interesting going on. If you weren't trying to solve some kind of a weird problem, somebody else might be. And so you'd run into that and be like, ooh, I can help. And so it was always very interesting, and ADHD me thrived with that kind of an environment. But they turned it into algorithms, and they turned it into algorithms where you do this, then you do this, then you do this, then you do this. And it became soul-crushing and uncreative. And in the meantime, I was doing projects for festivals and stuff like that. And that was my creative outlet. And it started to get in the way of work, get in the way of my work. And at the same time, I think they were trying to get me to quit. They were trying to get me to quit by giving me these awful tasks that were just soul-crushing. And so, you know, being a little bit overcritical of everything that I do. So I was just, my only output was creative avenues. And I realized that I needed that in my life. And at a junction when I was jobless and gormless, I decided that it was time to whittle away my ego by streaming on Twitch. And then the pandemic hit. Yeah, that's my story. I'm listening and learning. I can't really help that much. I hope you're learning because I'm learning very little, and I'm going over the stuff that I learned that works, and a little bit of, like, you know, reading circuits and stuff like that. I'm okay with, like, logic level stuff and things, but when it comes to, like, audio stuff, they're always squirrely about the numbers that I need in these data sheets. They don't give you what we just ran into. They don't give you a voltage. Although this one did. The, hold on, let's get rid of some of the clutter here. I have too much clutter. This is why hopping from thing to thing is starting to, like, my ADHD brain is exploding. This is not mixing for a headphone output. This is mixing in order to output to Eurorack. So in the end, we've got the transconductance amplifier just going directly out with a TL074, which this is essentially similar to the circuit that I have without a 490 kilo ohm thing there. Hajiwo makes very simple circuits, and they're cheap. He's a wonderful maker. He's like one of my favorite channels for Eurorack. And so if you're looking for a design, I gave myself the hiccups by talking emphatically for a minute there. Let me just get a big swig of this. So we were looking at mutable instruments in order to make a mixer. We found that Emily Gillette, legendary modular synthesizer creator, used the V2164. So looking at the V2164, I then looked for a Hajiwo circuit that used it as a mixer, a voltage controlled amplifier. And so Hajiwo uses this strange scheme in order to get a voltage out of this thing that you can turn into a linear voltage, and it uses one of the amplifiers in order to do that. I think we are only going to have, sorry, logarithmic. He turns it into a logarithmic voltage using all this stuff. The amp up in the middle is a huge question mark. So in Eurorack, you've got voltages coming in. And I guess what's going on here? This is turning it into a conductance. And then we have an op amp with just a 100 PF acting as a buffer. It's a crazy weird circuit. I don't know how he figured that out. Because this would be driving current from whatever voltage is coming out of here, and then 100 PF is the only feedback. That turns it into doesn't that turn it into an integrator? So you would need to have a changing voltage like that. That doesn't make sense. ACL, what's going on? All right, so the Hajiwo circuit is mind-bending, but Hajiwo makes very simple circuits, and so I tried to find something from that. We can close this because I think it's a little bit confusing. Yeah, It's kind of distracting us in its weirdness. Maybe something that we would it would bring light to actually building IRL. I've ordered the chips from DigiKey at a paltry $3 each. I think I got a 10 chip discount, and it was something like $2.80 each. That's really expensive for just one chip in the rest of your design. $3.96. $4 a chip? Are you kidding me? That's a soda. It used to be 4 sodas, but now it's 1 soda. But man alive. Okay, so we're done with DigiKey. We're just in the data sheets here, and we're just gonna build stuff. Let's just build the circuit. What I have right now on the PCB is similar to what I have in Notepad. What we have is a signal coming in here from the Euro rack, and so it goes this way, is the typical direction of my schematics. We have what is essentially going to be a plus minus 12 volt signal coming in, being converted into current, I suppose, through this thingy-majig right here, and then that current is then amplified or damplified by the voltage-controlled amplifier. It is then output, and because we have 4 inputs, we have right 1, left 1, right 2, left 2. Jeez, I don't have the resistor here for the normalization. This is where we might run into a problem. I may need to have a buffer op amp here. And remember, every op amp that we add to this thing, an angel loses its wings. We have very little space in order to build our circuit. Every single one of these is a dick punch. So we've got to make sure that our dick remains bruise-free by minimizing the amount of op amps in the design. And if we're lucky, we'll have room for clipping indicators, which are 4 more op amps that I don't want to have. So what happens is we come in here, and the voltages that we can provide the chip with will dictate how the left and right channels independently are amplified. Or why is it's amplify and brain amplify, and I've been saying damplify, but that's not right. It's not damplify. It's carry the one. It's attenuate. If I amplify or attenuate, why do they have to be such different words? Anyway, boost and cut. Yeah, essentially, boots and cats is what I'm talking about. So on the output there, we then mix the channels together, but it's not left and right into a smeared left and right mono. So we keep it stereo, and they're all controlled by the same thing. So we have a big master volume knob that's independent of our mix. Independent of our mix, that's important. That's pretty much one of the only things that I can provide Julian with, is that the left-right is going to be independent of the mix of the rest of the thing. And so those are the stereo channels that then come out in current form on the outset here. Now, I'm doubling up on the amplifiers. If we need to make these logarithmic, I guess I can sacrifice one singular one of these for each. And I could use one for the volume control, and then the other one can be for the overall volume of our mix coming out. So once we adjust that volume coming out, we then need to put it into a transconductance amplifier, where it is then converted into a voltage. And that's why I'm so concerned about voltages. Is right here, I believe, and I can't confirm, that we might have a plus minus 12 volt signal maximum. We might have a plus minus 12 volt signal, in which case we need to get this thing down to question mark. And it's 6 amplifier chips. I'm going to get rid of this. So that would need to be a 6 volt peak to peak, which means it's 1/3, or no, 1/2 would be the transfer function. So it would actually be a 50K here. Well, no, 12 into 3, that's 1/4. Jesus, I'm so bad at math. I'm so bad at math. I need to do I think I need to do exercises. Exercise. So that's 25K. Let's just get rid of the, hold on. Let's just Problem is I don't have a plus minus 12 volt signal that I can give to this thing. So this would be 25K. I think that's what we're getting at. And since this is a differential amplifier, I want the opposite signal down here. I don't know why I have the exact. Oh yeah, this would have to be a. This would have to have like another resistor on it. Or no, that's coming out of minus and it's going to ground. So it'd have to be, yeah. I think that's. We'll test it. We'll test it. So I think we're doing 25, and we're not using an MCP 6004, which means that we can blow up our chip if we give it way too much current. But since it's only getting a plus minus 12 volt supply, it shouldn't be able to get the TL074 to go into destroy your stuff mode. You could use 2 inverting unity gain stages, one after the other, to have a differential output. That's what I was going to do, and that's what I actually have wired up. That's what we're looking at now. That is 2. One of them is the transconductance conversion, right? This is the transconductance amplifier, and then I followed it with a unity gain output. All 4 resistors can be the same, like 10K. But then I blow up the audio amplifier chip, right? Because the chip that these are going into, 12 volts would kill it dead. So 6 volt peak to peak, that would be 1/4. And so we do 25K, which I might actually have. So that would be 25K and 100K. So let's put this together. Let's see if this works. So this is a revision of this that takes into account the voltage shift. And basically what we have here, this is what I have on the breadboard, right? I don't have all of it yet, but I have this on the breadboard with one single amplifier going into things. We get to discover whether or not putting multiple controls on this thing is going to do weird stuff if I need an amplifier there. So yeah, let's reconfigure. We have an opportunity to reconfigure. I'm going to turn off the output. Bop. And so let's see, our 2 outputs will be the same, but I'm going to rip up most of the circuit. Wait, but we still have, okay, transconductance amplifier output going into this input. Okay, so let's take this away. Let's take this away. Let's take our ground away from this specific amplifier. And then we'll have our limited signal coming out of, like, for instance, here and here. So on one of them, I am putting the plus to ground. So it goes plus minus output, 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 output. The output is on the edges, and then it goes output minus plus. They put the minus right next to the output so you can have a nice circuit layout for your feedback. So plus is going to ground. And of course, this plus is on a gap in the breadboard. It's just to mess with me. It's just to make me angry. It has to be like that. So this is for the inverting amplifier. So the inverting output, we have in line with the inverting output signal, we have a 100 kilo ohm resistor going into minus, and then a 25 kilo ohm resistor going into the feedback. So 25 kilo ohms across these two. Let's see if we can get that real quick. I think we sussed our way through that, although I'm not totally confident in what we're going to see on the outset. So there will be some possibly destructive testing that we'll do when I get the main chip in, which is up to DigiKey and whatever the cheapest shipping is. Unfortunately, this shop is not funded like your office might be, where it's extremely expensive to have somebody waiting on a chip. Here, it is extremely cheap to have me waiting on a chip. So I've ordered it. It's on its way. I wish I could get that good shipping that everybody seems to get. But we're not, I mean, we're not like a popular YouTube channel. I'm happy for the viewers that I have. You guys are amazing. Why is my arm tickling? Is there a bug on my arm? No, it's because everything's dry. It's very, very dry up here in the Northeast. So dry. So here's a 100K, and I'm just putting it in a configuration where I can connect it directly across the output. We're not going to worry about capacitors right now, but I mean, I think later on we're probably going to want capacitors because this the signal has some high frequency ringing noise to it. just by virtue of the way it's designed. We'll see what we get on the output. But okay, I'm trying to get. Wait, this is the 100K. Oh yeah, this doesn't go there. This actually on the other one, this goes between minus and output. And then I have the 25K going to ground on this one. Okay, so sorry, a little bit weird. We have an inverting and a non-inverting op amp, so both with a gain of 0.25. Wait, does that work mathematically? Hold on a second, because it's for the non-inverting, its gain is equal to 1 plus R1 over R2. So if R1 over R2 is a quarter, then it's 1 1/4. We'll see what happens. So there's that 100K, and the next 100K is our signal input. What should I do about that? I think what I should do is run the output of this one to like a common spot, and that way I don't need to squish a bunch of wires in on this right here. Although it is kind of fixed as going to those two, so I could do like a flying resistor, but that would be a little sloppy. Let's run it down and over, and then I can do the input to this one. I can put right there. So we'll do a yumper. How long of a yumper? Take one of these long ones. We'll just offset it by a lot. My input signal is unfortunately this thing. So from the output there, it barely can reach, but it'll reach this sort of blank section right here. And so we have a 100 kilo ohm that goes between these two. So I'll need to make another one. Another one of these. It's not going to be the cleanest signal path, but I think it'll be useful for us. And that's actually going to minus. Yeah, this won't span it. So we need to do a 3-jump resistor. This is how it works. You start with the napkin, then you pour over the data sheets and lose all hope. Start to bargain with a higher being, a higher deity, and then you come to conclusions, and then you question those conclusions by virtue of the circuit that you build. It's just how these things work. And then that's 100K on the input, and then we need the 225Ks. So I need to actually find and see if I've got anything close to 25 kilo ohms. And then all your numbers get scrambled when it gets to actually applying the circuit. They all go crazy. Oh, cool. 7K5 jumps to 8, 15, okay, 22 kilo ohms. What effects is that going to have? 22 goes to 47 because I'm missing 33. Well, we'll be a little bit out of spec, and maybe I can buy resistors, but 25 kilo ohms, not 12.5. That might be the issue. I might need to put 12.5s in there, but it's a quarter. I'm trying to quarter the signal, draw and quarter the signal. We'll see. We'll just see what happens when I put 25 kilo ohms in here. We should be seeing a spread of plus minus 1 volt, I think. That's 125 kilo ohm, and that one is going where? Going between output and this thing. It's right here. We got to answer these questions one at a time. Otherwise, we're going to be running into some issues. My original idea for this circuit has gone completely out of the window. I had a great idea for what this thing was supposed to be, but it has changed now quite a bit. That's going straight down, and I'm just going to give that a little cut, give it some distance, and then it is going into this filter, this comparator, on the plus pin. So that's all the way up here. So I guess what I can do is move this out a little bit. So feedback resistor. Oh no, wait a minute. No, it's not. No, the signal goes directly in. Okay, hold on. So that I already messed up. So it's actually this minus pin that goes to ground. So it's actually this one, and I'll just do. I'm gonna make it. It needs to be out just a little bit, so I'll use the tweezers, give myself a little space there, and just bend this straight down. You can use the TPA without a differential input if you need to. Yeah, I kind of wanted to do the differential, though. I don't know why. I think it's better. better noise rejection, maybe. Although putting it through more op amps in lieu of just making it a simpler circuit is something else, too. I don't know. What do you think? Adding the complexity is maybe a bad thing. But I'm doing an inverting and a non-inverting amplifier on the output. And then this just goes here. So I need passively, oh, that might already be, might be pre-bent. Check. Not quite. That one's seen better days. What do I have in that size? Another one of these? Give it a little bend. See if that fits the bill. Well, for running signals between devices, I could use the other type of jumpers, but that'll do. That'll do just fine. Go with single-ended because it's right on board. It does mean that I need fewer amplifiers to do this job, but only 2 fewer amplifiers. So I don't know. In a world of quad op amps, well, let's try this, and we can try single-ended too when the chip gets in. All right, so the output here and the output here are going to the scope. And so if I turn this on, what do we get? We get a much smaller signal. That's 600 millivolts. That ain't what we're looking for. And boy, howdy, is that noisy. Where's my other one? Where's my other signal? Oh, it's not at 600 millivolts. What's that channel doing? Channel 3. 0 volts, 2.5 volts. Oh, channel 3 is DOA. My differential signal is not exactly responding to this. So that's this one. Oh, because I hooked it up to plus 12. Okay, hold on. Sorry, I hooked it up to minus 12, not ground. This is supposed to be connected to ground. It's supposed to be referenced on ground. Derp. I keep doing this. I labeled these things so that I wouldn't get that wrong. The labeling is useless. It does nothing. Okay, so it's going into the plus input, and then the minus input is referencing off of ground with a 25 kilo ohm, which I think is probably the wrong math, but we'll just see what it is. Okay, and then I give the output again. Wow, why is the millivolts are bleeding into the output? Oh my God, what the heck is going on there? We got like major clipping. And this thing is on a 10-volt scale? That's so very wrong. Okay, so some things didn't go as planned. Some things didn't go as planned. A lot less noise when your signal is plus minus 10 volts. But my equation turned out to be multiplicative of the input. Wait a minute. How to non-inverting amplifier. These are like ECE 101 questions. Non-inverting amplifier, V out over V in is equal to 1 plus R1, R2 over R1. 25? No, that's 100 over 25. That becomes not what we needed it to be. V out over V in is equal to, what is our V out over V in? We want 1 over 4. 4 V in is equal to 1 V out. So 1 over 4 is equal to 1 plus R1, R2. So negative a quarter. How can we make negative a quarter from R1 and R2? I can put negative resistors in there. I want the transfer function to equal 0.25, 1 over 4. That's 1 over 4 is equal to 1 plus, and then I need to somehow turn the 1. It needs to be, it doesn't work. It doesn't work. I don't think it works. I don't think it works. If I swap the two, am I going to get down from 10 volts? It's going to be hard to swap them because of what I did to the leads. Oh, my leads. My liege. There you go, like that. And then I can kind of cheat this by, oh, that's going into the output. Wait a minute. It's all wrong. Everything is so wrong. This is way over my head now. What, because of one math equation? We can get this. We can get this. We can figure this out. We're doing basic op-amp circuits. It's not, where did my resistor go? Where did it, it's gone. Where did it go? What the fuck? It's gone. It's vanished from the board. It flew out of the tweezers and went somewhere. I just use an online op-amp calc. I should just look one up, yeah. But how does, with the 1 plus in there, how do I damplify enough to make the proper, oh boy. Which one is it? Okay, hold on. I gotta find my resistor because it blew up and it flew away. Where did it go? This is why we have the multimeter in the wings ready to go in ohm mode so I can find my stupid resistor. Yeah, exactly. Well, this is part of what we're doing is hammering away at it in order to figure out what's going on. That's 39. 39. Both 39s. What's this one? Another 39. 39s I was using in lieu of the 33s. Yeah, I think the math is a little skewed. I think this is 33. I'm looking for 25. That's a 10. What's a 10 doing here? Wait, shouldn't you be 100? 100, yeah, this is 100K. We'll put this one to ground. And then I need to look for that other resistor because the resistors are round, and so these tweezers, when you squeeze on them, they'll fire the resistor out of the front. So we'll put 100K to ground, and that'll be R1. And then R2 is going to go between these two, and that's going to be, no, R2 goes from, yeah, it goes on the feedback. So that one needs to be 25K, and I don't know where it went. I know this one's not going to be it. 1K, that's not going to help us. Where did you go? Where did you hide, resistor? I got that decade box, but I don't really need the decade box to do this work. This is fiddly. I mean, we get to play with numbers a little bit, though. As much as I like to be informed of what our next move is going to be, we do need to just play around a little bit and just get things where we like them. And I guess I can toy with the non-differential mode. Using the non-differential mode, we would just have the inverting amplifier that we just set up, the one that works, and it'll just go into the next amplifier where it'll be catered to headphones. That's the important part about it. I don't know if we could limit the transconductance amplifier, because all that's doing is turning, I don't know where this resistor went. It like vanished off of the face of the earth. I don't know how it could be. Where did it go? It would be over here. Over in the wings over here? No. Here? Caught up in this? Nah. What the heck? I have a 20, what was it, 22K sitting around here somewhere. Hey, what's up, Gonad? Yeah, I'm trying to look for a resistor that shot out of the front of my tweezers, and I don't know where it went. Oh god, and then a giant truck is going by outside. It's garbage day. Garbage day. No, wait. So they're picking up 2 weeks of my garbage. I forgot to get it out last week. We tip them very well here. But we're spelunking our way through audio circuits, and analog audio is not really necessarily very easy. When you're coming up with all the stuff on your own, I guess it is. We have a headphone amplifier in this thing. So there's this chip that just acts as a headphone amplifier, and I figured that would be nice and easy for me to design around, because then I wouldn't have to worry about all the impedances and stuff of headphones. I just have an example from TI, and they tell me what to do. It's another 39. I'm going to get another resistor. I hate to do this, but I have to. I'm just going to get another 20, whatever, 25, 22. I don't know where it went. Go. Put this in pin next to pin mode. Give it a little clip. Even out the leads. We can drop it down into the circuit with the power supply off. Boy, if my audio signals are going to be at millivolt scale, there's going to be significant leakage. I mean, look at that. So that goes on to from the output to the minus, and the minus goes to ground. And then we turn on the input, and this is now, this is now controllable on the millivolt scale, because I did the opposite operations. So if I take this channel, we're looking at it right now, and I turn it down to, it's still 4 volts though. 4 volts is not what we're looking for. Actually, it is, isn't it? It's the non-inverting one that is a little bit uncooked, because we didn't quite get to the full value. If we did the full value of the resistor at 25, it's at 22K right now. So I think that's why it's going a little bit above our sort of, well, it's supposed to be around 6 volts. So it's actually below the 6 volt limit that we set for this. Well, plus minus 3 though is what we should be seeing. And we're seeing plus minus 4. So yeah, it would need this resistor would probably need a little bit of adjustment. So what's going on with this one? Why are we so tiny? Why are we tiny little signals here? Let's see what we've got. We've got 100K going there, and then we have 25K on the feedback. I think that's how it's supposed to be. But we're like super duper damped. And it'll do. Yeah, that's like quiet as hell. So this will put it on the same scale as the, it's like half. What is you doing? What is you doing? Are you limiting my input? Let's check. Okay, so R1 over R2 for an inverting amplifier circuit. Wait, is that, which one is it? It's the non-inverting one. No, that's not right, because we just changed the non-inverting one. Non-inverting one is this one. Oh yeah, because the inverting one flips it back to where it was, because the V2164, the amplifying chip that's doing that one actually inverts. So, or no, the transconductance amplifier, gotta get out of here, inverts it. And so this flips it back over. And so that's what the light blue trace is doing. But it's way too damped at the moment. Non-inverting amplifier transfer function is R1 over R2. In this case, no, this is, wait, we want inverting. Amplify. Why is my typing always off home row today? Amplifier circuit. S. Circuits. Circuits. Introduction to the... No, that's the wrong one. There's like a 10... Yeah, top 10 fundamental. This is just like a page that I keep going back to. It's got the fundamental amplifier circuits. We don't have to be smart. We just have to be able to reference everything. So our transfer function for this one is Vs is equal to negative of whatever the voltage is times R2 over R1. And so we want R2 to equal, well, 1 over 4. Oh, I got them backwards. That's why. I had 4 to 1. I want 1 over 4. That doesn't, wait, hold on. So if I've got 1 over 4, it's 100K divided by 25K. So it'd be 100K on the feedback and 25 on the input? That doesn't make... Let's just try it. Let's just try it. Let's try it. Turn the power off. Pop. Swap the resistors. I mean, we get to do this because we're in this sort of walled garden of our plus minus 12 volt supply. So we get to kind of play around with values and figure out what's best. That's what you guys signed up for today. Father, we didn't sign up for anything. I just clicked on this website. Shut up. Ah! Where did that go? Why did they do this to me? Why did they do this to me? Okay, this one needs to spread 3 pins, and I need to not drop it. I'm going to put it in with my hands, my big meaty hands. This one needs to go to the input. And the one that flew away, which I need to find, needs to go to the feedback. There it is. All right, so that'll go right here. And so now we have 25K on the input and 100 on the feedback. That doesn't seem right. That's not what the other circuits look like. Ah, whatever, let's try it. Output on. Bam. Oh my God. So that's way too many volts. That is not the same effect. I think we need to alter what the math is doing. I think the value of the resistors needs a little bit of work. I was doing it as a 1/4 of the volts, but that took us down to a millivolt range instead of a volt range. I take that all the way down to there, because remember, we want 6 volts, so 3 volt to 3 volt, which is kind of close to what our other signal's doing. Not really, though. And actually, on top of that, we want less than that even. Hold on a sec. We've done a couple things that have, yeah, we're way off. The values are way cooked. Our input signal is plus minus 3 volts, right? So we are mega amplifying our plus minus signal. Now, obviously, we want to have the ability to turn up quieter signals on this thing. But at our maximums, so what I'm looking for at the output is, and we agreed upon this, is a 6 volt spread, which is plus minus 3 volts. You could make it 0 to 6 volts if you just put a capacitor in the line. But anyway, so it's 6 volt plus minus, right? That's what we're looking for. And sorry, 6 volts plus minus, and we don't want it to be inverted in any way. We want it to be just what the input volume already is. Although, is our headphone amplifier going to invert it? Because it is shown as an amplifier. So maybe we want to invert it. But either way, I wanted to make a plus minus signal. So plus minus going into this thing, 0 to 6 volts. If we make our 3 volts into 6 volts, we're going to be hitting this device with something that, like, you know, an synthesizer outputs that would be like 10 volts. And then our 3 volts is no longer 3 volts. So we hit our chip with like 12 and it blows up. So either way, our amplifiers are crazy right now. Something weird is occurring here. And it's due to our inability to do math. What I could do is put potentiometers on these things, and then I could just adjust it with a screwdriver, and we get it to be within the right range. If we're taking in 10 volts and we're turning it into 6 volts, that is going to be 10 to 6 would be the ratio, right? 10 over 6, which if I do the calculation, this very simple calculation in my brain, and don't do it by pulling up a calculator, I can tell you that 10 over 6 is going to be 1.6667. That doesn't make any sense. That's how many times 6 goes into 10. 6 over 10, but that's 0.6. So what is my ratio going to be? Is it going to be 100 kilo ohms and then what N-Bandit said, 12.5K? I don't know. Let's look up an op-amp calculator. Shut up, shut up, shut up. Op-amp calculator. That's a VMAX with 12K. 100, 12, let's turn these to K. Input amplitude of 10. Gain of 0.12, output amplitude is 1.2 volt. But this would be maximum. We want it to be a little higher than that. 25 is what I said. That gets us to 2.5. So 39 is almost 4 volts. 33, 1/3, gets us to 3.3 volts. So these are all the numbers that we saw in the mutable instrument circuits. We saw these numbers all over the place. And I've got 3D3 kilo ohms coming in the mail, but I do have this resistor kit. We can get one out. We see this all over with mutable instruments. Only mutable instruments doesn't allow it to be plus minus 3.3. They put in I think a much larger resistor. It's 25 or something, and then they offset it so that it's DC. But we don't need to offset it. We can just have a single end non-inverted version of this. But what is, wait, A is equal to 1 plus R1, R2. Diagram view, this is inverting op-amp gain. I guess we need to look up non-inverting op-amp gain and see if our calculations are anywhere near that. Let me get a 33K resistor though. Let's hook up a single end of this and get it to properly put our voltages into, because I want to actually test, the thing that I want to test next is whether or not two voltage control signals need a buffer. Do they need a buffer? Do they not need a buffer? What is a buffer? How is a buffer? Is it a dog? It sounds like a cute dog that goes buff. Oh, I'm stretching. Hold on. I gotta stretch a little bit here. Flatulent Gonad gave you a shout out to 35 viewers 4 days ago. Oh no, that's not a modern. We don't have a lot of updates lately. Got a good number of viewers though. I'm happy for the people that are here. Don't forget to get up and stretch every now and then. Sitting in general just for too long is real bad for you. Really, really bad for you. Okay, 33K. Some of these are appropriate wattage resistors, but they all have the very thin leads. So it's very, very frustrating to look through. These even in any kind of an order. Here's 2.2K. We're looking for 33K. 33K, 10K. 5.6. This does not appear to follow. 330 ohm. Oh, jeez. This is going to be tough to find, isn't it? The one I'm looking for is 33 kilo ohms. 2K. 1.5. 1.2. They're in some order. 1. Okay, so we appear to be moving in the appropriate direction. What are these at? 100. 120. Okay, so we're somewhere over here. 47K. We're close. I can smell it. 5.6K. Wait. 47. 5.6. Oh, jeez. 4.7. 5.1. So we're close to the front? To the front or the back left? 1M. No, not quite. Not my tempo. 550. Let's go back here. 22. Ah, jeez. These are in the worst. What's up, dog, with you? Not much. What's dogging? What are you bird dogging up? Wait a minute, is it even in this kit? 3.3. 22 and 47. What a bad joke. Son of the bitch. All right. I can make 33. I can put two together, make 33 out of it. It's going to be tougher for me to do surface mount with that, though. I have 39. What effect does 39 have? Because we could just pretend until my 33s get here. 39 brings us to almost 4 volts. All right, let's do that then. And then we'll have to look at a non-inverting calculator. So 100 feedback resistor, 100K, 39K. Input is 12 volts. It brings us to 16. 39 and 100. Yeah, see, like we can't lower it into fractions. We can't turn it into the fraction that we want it to be because it's 1 plus. So we can't invert it. That's so weird. Why can't we invert our own signal? I mean, like if I have unity gain, it would be like what, like 0, 0? Not a number. 1, 1. 2 becomes 24. 4 to 1. 1 becomes 15. 6. 12. 1, 1, 1, 1, 1, 1, 1, 1. It's always going to be fractions of 1. So whatever's going in is coming back out. Curse you, inverting op amps. You have to have, like, I would have to pull in a voltage reference or something. Or you can take it before and after, but then, man, 2 inverting op amps. So we're having math issues. So yeah, the inversion thing is not really going to work. We can go to single-ended, and if we do, let me just turn this off so I don't blow anything up by hot plugging these things. I can get one of these three nines, which this one is, and I can use that in the feedback. And I'll move the 100K. Math is for nerds. So we get the 2 point whatever out of here. And the 100K becomes our input. Spread that out a little bit. 100K becomes our input. Actually, we can do away with this too. We can do away with this adapter here. And get rid of this feed through. Come on, give me this. Gimme. There are better tweezers for breadboarding. I had a breadboard kit that came with these tweezers that were kind of awesome for what they were. What they would allow you to do, they had little like grippy, nubbly things on them. So they were actually able to grip what I was trying to pull out and put in. Are you pulling out what I'm pulling in? Yeah, I think you are. All right, so let's put this all the way to the other side of the chip with the 100K. And I'm using my super expensive piece of plastic, which is just a little measuring caliper for gapping these breadboard stuff. I haven't seen a direct replica on Thingiverse, but boy, you know, a direct replica would not be difficult to make. Let's be serious here. You just have a pointy end, which is kind of hard to 3D print. I mean, you may have to do a resin printer to do that. You could get by with some stuff, and I've seen somewhere, in order to repair these, they've actually just like sunken like a pin end, like a tack end, or just like a piece of a lead into the end of this to make it pointy again. I was thinking about doing that, but maybe some other time. But anyway, you could do like metal pointy pieces, and then all you would need is a track for it to follow, something to screw it into the track, and then this is the sort of pièce de résistance. This distance here is an ideal distance to go into the clip of the breadboard. And that's all you notch with the distance on it. And you drop your component on it and bend the leads, and Bob's your uncle. There's other helper tools on this thing, but they're not necessary for the main thing that I use it for, which is to do that sort of jumping. It's just the lockable pointy end that is even with the bend area so that you get things positioned just right. And this thickness is half of 0.1 millimeter. No, 0.1 inch. That way, the location that you measure the hole, well, actually, no, this is located so that the bend here is in the middle of the point. That's all it needs. Bend in the middle of the point. That is totally a 3D printable thing. I should probably make it and put it up on GitHub, and then Pace will come after me with their lawyers. Our sales of our $75 piece of plastic have gone down because of you. Prepare to be imprisoned. This goes from there to the negative input. Yeah, okay, good. I measured the right thing. I wasn't paying attention. I was on autopilot, ADHD autopilot. Yeah, it's a surprisingly useful tool. It's actually shocking how useful it is. All right, there's that, and then we put the 39 ohm across input to output, and then on the outset we should see an non-inverted signal that goes from very low volume all the way up to, and we need to change the units here. Why is it in sub-millivolts? What the hell? That ain't the way it's supposed to happen. Hold on a second. This is the channel that we are looking at. This is me turning it up. This is me turning it down. Oops, turning it down, turning it up. All right, let me put you both on the same channel. Why did it suddenly come to life? Was it that this thing is... Am I looking at the output? I am looking at the output. This would be the output from the transconductance amplifier right here. So that's a much larger signal. Well, actually, that goes up to 3 volts. Oh, because we're inputting 3 volts. I'm not inputting 10 volts. I'm inputting 3 volts. So we are seeing what would be translated into... Yeah, we're not at max. We are below max, which is getting us to the scale of... Yeah, about 1 volt. So our non-inverted signal, our inverted signal is coming in, and that's at 3 volts. And because we're going, our ratio is, what was the previous web page? What did it say? It's a 39.39. So we're coming in at 3 volts, so 3 times 0.39. And I'm doing math in my head. I'm not using the calculator. I'm doing 3 times 0.39, and that equals 1.17. What? Our gain is 0.39. Yeah, 3 becomes 1.17 volts. And that's actually about what we got. Because it's math. All this stuff is, this fucking shit is math. All this stupid crap is math. It's just math. That's all it is. It's just math. Oh, my brain. Yeah, this is why we test stuff. I mean, this is why we have solderless breadboards, is in order to just kind of like, when all the chips are down and you've been doing math all day, you just go, I want to see this thing in real life. And you just put it together, and then online converters with electrical engineering stuff are just, they're amazing. They're so good because you don't have to think. I can just, let me put in a number and dead reckon this. That's sort of how I came across the resistors in order to get close to our maximum swing from the potentiometers. Now I'd have to do additional calculations. Noisy signal? Yes, it is a noisy signal. Look at all that noise on there. And by noise, we mean this. Hold on. We mean these things. Those little fancy doobly-doos that are on our signal, those little cool-looking bips, little blips that we got. Let's make another 120 PF feedback capacitor and see if we can get rid of some of that noise. It doesn't really appear to be common mode noise, but it might be something happen intrinsic to the breadboard or the flying op amps that don't have a task. If I touch the resistor, obviously, I am giving it 60 hertz feedback, but works only on the breadboard. No. This would work better off of the breadboard because these resistors have such thin leads that, like, you can break contact by wiggling the resistor around. Some of this might change if I actually touch the desk. Why did it stop? Why did it stop when I did that? Weird. But yeah, that is noise, and it is filterable. Let's try to filter it, and then we'll play with the outputs from this thing. So what I'm do is I'm going to get a capacitor. And the only capacitor that I have in this value is surface mount, but it's supposed to be a 100 picofarad. I don't have any. So I'm actually going to put in a 120 picofarad. When it comes to capacitors, I mean, like getting close is fine a lot of the time. We're not super specific on what this noise is that we're filtering, and we're not really sure if this noise would even show itself in the final design. So it'll be good to have pads for the capacitor. If we luck out and my design is clean enough, maybe we won't even need them. But this sort of harmonic noise that we're getting, these little spikes here, are filtered out by some op-amp circuits. And so that's why they use that OPA, whatever, in all of the examples. Yeah, well, the Agilent power supply is really, really good. This shouldn't have very much noise to it at all. And in fact, on the output, rather, that's the input. So what do we have on the output of the, this is, so now the purple trace, or whatever that is, what color would you guys say that is? Whatever the hell fuchsia this thing is, that is the output from the transconductance amplifier. God, I'm saying trans as much as these fucking news pundits that want to take away their rights. All right, so this capacitor right here is filtering out that noise. If I get rid of that capacitor, oh my God, we get tons and tons of that noise. So possibly I could defeat it at the very beginning of this. Maybe the capacitor is intrinsic to the TL074. I don't know. We can try putting another one in. I got one out of the bin. Let's put another one on the next stage and see if that helps quiet it down a little bit. So in order to do this, in order to get these surface mount parts onto my through-hole board, what I can do is just grab a socket for through-hole use. And now the special sockets that I have are these low-profile sockets. And what they've got at the top of them, I can find them underneath all of my straight headers. If I can find them, basically we just will have two flat pads that I'm able to solder apart to. Now to do that, I'm going to put it into a blank section of the perforated prototype, or the solderless breadboard. You think it's just wire distance that's doing it? This big honky thing right here? That might be. I could replace that with a shorter jumper maybe. Okay, so what I do is I put this thing down, and then we get the soldering iron, and I get up on the microscope, and I'm just going to use the female. Oh wait, no, I'm not going to use this one. This one is a larger hole, and that larger hole can actually take leads from components, and I want to keep those. I want to preserve those as long as possible. I have ones that I bought accidentally that have very thin holes in them, and I want to use those up. So I'm actually going to go fishing again into my bin of sockets and stuff, and I'm going to find one that has thin hole. Yeah, see, this one's much more narrow. No, it's not. Hold on, that might be the one I'm trying to save. I should probably put them in a different bin. Maybe that's the strategy here. Perhaps I've misjudged you. Yeah, those are they thinner? Different polarity, isolated wire, too close. What do you mean? I don't get that. I don't that in the context of what the circuit is doing. That doesn't make sense. See, when they sell these, they're only compatible with the round pins, and there's other ones that have larger pins. I think these are the smaller ones. I tried to order the right thing, and now I'm inundated with the more narrow pin headers. Yeah, these are a different style. They have a different thing on the back end there, and they've got a much wider hole. These are good for, like, if you want a low profile mount surface, or if you want through-hole stuff that's low profile on your proto board, these are great. These are not, because they're so tiny. These are good for the rounded, low-profile pins, though. So if I'm doing like a standoff on a board, I'll do it with this. What I can also do is just cut 2 of them off of the end here. And to do that, I use the wire cutters, not the flush cutters. So using the wire cutters, this gets like a better cut angle on it and makes it so that it cuts closer to the middle of the plastic of the thing that's holding the pins in, so that you don't get an exposed pin on the end. Cuts much cleaner. The flush cutters don't do that because they're offset. All the wire you have used, I use negative wires, yeah. That's not a thing. Negative wires is not a thing. That's not a thing. Wires don't have intrinsic polarity. But I'm also not, we're not doing differential signals. These are different stages. What's going on down here is you're looking at different stages of the op amps, because the op amps are in inverting mode, because we can't do what we need to do mathematically with a non-inverting setup. Non-inverting has that 1+ in the gain that we don't have anything to do with. So what you do is you stack inverting amplifiers in order to get your signal to be the right polarity and stuff. All right, let's so this is getting a surface mount component into through hole using pins that I accidentally ordered. So what I do is I just fill with solder. I don't want to apply heat for too long because these things are sensitive to heat. They melt. I think he's referencing the inverting and non-inverting amplifiers. I think that's what he's talking about, which is why I mentioned that we can't mathematically get the inverting amplifier to do the right stuff. I'm going to melt the shit out of this if I'm not careful. All right, so position it like somewhat even on the cups, and then this is a little hard to solder, but it is possible to solder this. And I have it plugged into the breadboard so that it's dissipating the heat, so that all that heat doesn't get concentrated around the plastic. It gets bled off into the track. And if I would really like to figure out how to do a thermal microscope at the distances that we're at. I think that would be really cool to be able to see the heat eddy, the heat propagate down into the pins and stuff at the scale. You don't have to worry about eddy currents until you get into RF. Eddy currents are not a thing in low voltage DC like what we're doing with audio. If you're doing RF currents and like you're designing a PCB with RF currents, then you can start worrying about eddies along the edges of the wire, but you need like a particular, like a very thick wire. So you don't really need to worry about that. RGB LED strip male headers fit those smaller headers if you still want to use them as header connectors. That's, yeah, I've ordered an equal number of the rounded headers. So every single, where are they? I have a bunch, I have another bin that's full of this type of header. But I have, where are they? I think I'm actually running out of headers. But I've got a ton of the rounded male headers as well. So whenever I need to do like a perf board or like a board standing off of another board, I'll use the little, and these are the ones that are, they're slightly better contact out of these, I guess, compared to the square ones on the females anyway. Or the socket ones, I don't know if I should. Anyway, these have slightly better electrical contact, and so they use them in the RGB LED strips. I use them for board standoffs because they really hold on tight, and they're very flush. They're not very tall off of the board. So I have a ton of this stuff, and that works with the smaller hole female ones, but I would like to find the larger hold ones so that I can have a great time. I mean, so that I can do like through hole stuff. Although it hasn't come up lately because I haven't really been doing a lot of through hole. Okay, so we're going to apply this filter to our other op amp output, and that should clean up our signal a little bit. I didn't even turn off the power for this. It did fucking nothing. It did nothing. And nothing happened. I mean, to be fair, this is outside of like hearing. You wouldn't hear this. You wouldn't hear this in the audio, and it will probably be filtered out by the headphone amp. But we can try. I can try a shorter wire run, but I don't know if that's really going to save us. And then that current wouldn't be present on a what do you call it? If we use the amplitude the whole way through, which is what we're going to experiment with next. It seems like I have to do a single-ended. I'm not doing differentials anymore because I guess our signals are coming in not as differentials, so I could throw something in and have it go the opposite way, but it accumulates to a point. Then false signals, there's not enough distance, at least on an 18-wheeler. We're a little tiny audio circuit on a breadboard. We're not an 18-wheeler. I think of myself as a type of truck, but my name is Buck and I like to truck. Where are my capacitors? I got the whole thing of through-hole capacitors. Look at all these caps. We can try throwing a cap on our power supply just to humor some of the viewers here. Let's get a nice meaty 470 micro 16 volts now. I'm going to throw a 50 volt capacitor on this thing. I do not want a value that is so close to my power supply. Because shit happens, especially when you're breadboarding. These are all lower voltage. What about 50 volts? Let's see. 16. I mean, these are gold caps. These are the cream of the crop kind of thing. 25, 220. I guess I'll accept that into my heart of hearts. This one's 220, 25. All right, turn this off. Let's make the leads even. The multi-distance leads on through-hole components are just so that the install is easier. It's easier to install something if you know that the long lead is your anode or cathode, and if you do one lead at a time, because you insert the one lead and then maneuver the other one into place to put through. But ground loop between scope and supply, maybe. I've got a lot of noise on the ground in here, so that would be very plausible. All right, so we're just humoring the noise, and we're putting capacitors between positive 12 and ground. So the potential in this case goes to ground, and we're putting one between negative 12 and ground. And remember, if you think of how these circuits work, we're talking about potentials. If you have a negative potential, it means it is a voltage level that is below ground. So in this case, our electricity is flowing from ground. So we put this so that our negative goes towards minus 12. Negative, very negative, less negative, positive. And presumably that should not blow up in your face. But you know what? We have not had a capacitor blow up here for a while. Power on. And that one's getting kind of hot. Turn it off. Turn it off before it explodes. Did I do that wrong? I don't think I did that wrong. Minus 12 to ground. I want the negative end to be on the more negative end, right? Oh, they're reflecting heat, but they are also getting hot. These are 25 volt caps. No, I did that right. I did that right. What are we doing? Oh, you know what? I also don't have decoupling capacitors in there. Modular synth input caps. Yeah, I did it right. Plus goes towards ground. I just don't know why they're getting. Why are they getting so angry? Wait, where's Gonad's comment? Why didn't that go to? Oh, where's my pop-out Twitch? Hold on a sec. My computer's trying to save memory, and it decided to like quiet down Twitch one. So Gonad made a comment, and then it didn't come through. Although I think it went through here. Not here. Yeah, see, it's right there. I don't really understand what you're saying with the wire distance stuff, but I know the signal was good. I just didn't like these heating up, even though the thermals only say that heating up. They're only heating up a tiny bit. Let me try to find some 50-volt caps because it did actually filter it out, and I think the noise is just coming from the current draw. As the signal comes in, the current draws. So maybe we just need some larger caps. I didn't like these heating up. They really shouldn't be heating up. It's plus minus 12 volts. These are 25 volt. They're gold caps, so they're 220 UF. You know what? I'm going to leave them in. I'm going to live dangerously. So plus 12. My rails are kind of weird because I wanted it to be plus 12, minus 12, and it's two separate rails going together. So I'm kind of cheating by putting the caps here. It would be like here and here is where I should put the caps, but this should be fine though. And then the line on the capacitor is marking the negative end. So if we go plus 12 to ground, and then this one goes from ground to minus 12. So this is in correctly. It's just when I turn on the power, they got warm pretty quick. Actually, they look pretty warm right now just from my handling it. Let's turn it back on. Boop. Maybe it's going to be okay. You can tell it's cold in the shop because things like that are like very, very much highlighted. It's kind of cold in here today. Maybe they're not getting hot. Maybe that was just for me handling it. Either way, our noise is gone. What if I get rid of this capacitor here? It looks like there's a little bit of that noise is present. I think it might just be from the hammering current draw of this thing operating. Because, you know, this thing is current based. And so if it draws and draws and draws, I think weird stuff happens. Where did our signal go? Wait a minute. Where'd you go? Where'd you go, second overlay signal? Oh, it's on top of the other one. Okay. Oh no, it's bottomed out. What happened to you? Did you just slip? Yeah, it just slipped. Here, let's pull our time scale out a little bit here. Oops, wait, no, wrong one. So I always hit the wrong thing. There we go. That's a little bit more easy to... Whoa, what is that phase delay? I guess that signal goes through multiple amplifiers. Yellow is our signal in. Purple is... Which one? Purple's going to be out of the transconductance amplifier. And then the blue trace is our output. And they may be matched up, but it's actually lowering the gain. So that's it. Look, there are no differential signals on this board. It's a single-ended signal. So we've got one output coming into the transconductance amplifier that's turning its current draw into voltages. And that current draw turned into voltages then goes into an inverting amplifier where it is then the same phase as the input. There's a little bit of a delay. That's just what needs to go through. Inverting the output somewhere. The inversion, why is this not updating? What is wrong with my social stream blade? I'm going to reload it. Maybe it'll come back. Doggy connections? What does that mean? Yeah, so I think everything is good as a singular signal amplifier with one potentiometer going into the amplifier. What we now need to do is simulate two different volume controls. Now, it's not really going to be a full system, but what we're trying to do is eventually have volume control and mix control as two separate entities. That's one of the things that Julian wanted. Two separate entities because you set up your mix so that your two lefts and rights are at the same volume as your other two lefts and rights, right? Your pairs are set up. What that's going to involve is having one potentiometer control multiple things. So what I'll do is we'll actually put together one piece of this. I'll just put the other potentiometer onto its own amplifier in the path of everyone else. We have 2 amplifiers still free. Where's the... What, is there still a little distortion on the purple signal? What it's coming from is as big of a question as I think you can get. I don't know. You're looking at that little part of the wave, yeah, there's just a little bump on it down there. I mean, that's a big question to answer. I don't know. That could be something to do with the TL07.4. It could have something to do with the other op amps that are there. It could have something to do with magnetic fields that are around this thing. It's a very small bump in the signal. It could also have to do with my scope and how my scope reads things back, although the other signal waveforms look pretty clear. You know, there's a lot of nonsense in electrical engineering. Oh, Code Rush rated with 7 viewers. How long ago was that? 30 minutes. I need to Code Rushed. Code Rushed, how are you doing? Everybody go check out Code Rushed. I'm going to shout out Code Rushed. I'm so sorry. Is it /SO or shout? No. There you go. Shout out, all one word. And then I'm on my own to Code Rush. There we go. We'll do a shout out to Code Rush. Code Rush is great. They raid periodically. We got 7 viewers out of that transaction. I missed it because we were in the middle of yelling at each other. A lot of stuff happened at one time. Yeah, I do not know where that noise is coming from, but what we're going to do now is we are going to put this signal through 2 amplifiers, and we're going to see if we can control them both at the same time. Measure device are EU optimized ground-wise. What? I'm not in the EU. I'm in America. I'm in America. Plus, I'm using DC voltages. So, I mean, I know you guys have different DC voltages in Euro than we do over here. Don't you have to go through like customs and a conversion? Okay, sorry, I'm talking out of my ass. Okay, so I either want to go through 2 amplifiers, or maybe I can like just double them up and just see what the effect of the volume control is on multiple things. Or we could mix a signal. I only have one waveform though. I only have one waveform that I can put into this at a time. I mean, I don't have that setup anymore where I could do multiple waveforms out of the AT-Tiny. Or the Teensy. I mean, I can hook up, we don't have well, I guess I could do jumper voltages. I can do jumpers over the VCO, and we can take a look at the VCO that's kind of untuned. Maybe we should do that, and we'll just have a C note that we can mix in to everything else. That's probably a good one. Okay, so let's get my VCO. This is a project that took us through quite a bit of Fusion engineering. I actually submitted it for like a review of the creative program that I'm being evaluated against in order to get a free copy of the software that I used to build this thing in the first place. This is pretty cool, right? What we did is we copied a Hajiwo joint and we applied input and output filter design from mutable instruments. So we took a Hajiwo circuit and we grafted onto it mutable instrument circuits, and then I rewrote all the software for this thing so that it wasn't crazy go bonkers nuts. Hajiwo puts together like a circuit a month, and in doing so, the software that it uses is not exactly trimmed properly to that sort of thing. It's kind of mad. So what we're gonna do, I'm gonna take another signal. We have another filter that we built right here, and so I'll power this thing up, plug the signal in, and then we'll have another full volume, I guess, because this is just a VCO, not a VCA. We'll have a full volume signal that we can then bring into our circuit and mix on the other end to our fixed output that we have. So we'll move this output to over here, and then these two will mix together and go to that. No, they'll still output from here, but their outputs will be mixed together. So yeah, we'll just put a little jumper in here, and then we'll have a second circuit that we can control, and I can see if I can double up the control wire without ruining everything. I think there's going to be a problem with that in doing that. So yeah, let's get this thing hooked up to power. Let me get some jumper leads and all that stuff. Bring you guys up and around here. There's a weird sense of scale to this shop that you guys I don't think really understand. Is that everything? I mean, those who are familiar with the stuff that I use will know the scale of everything. But it's strange because people will come in here and physically actually see my setup in real life, and they go, "It's a lot smaller." I get that a lot, but I get it in particular when people come over to the shop. And then I get it again when I show them my shop. All right, let me go get this. Ground on case. No ground case needed. We got direct ground wire. Listen, I got 60 hertz issues around here, but that was not a 60 hertz issue. That is just an intrinsic high frequency noise. And I think it's coming from ringing. I think it's the op amp ringing at a high frequency, which they say, don't put the capacitors in because it'll ring at a high frequency. And we saw ringing. And then I need a couple of these jumpers. I need 3 of these in order to make all the voltages for modular synthesizers. And then I need a power cable for a modular synthesizer. I don't know if Speedy was confused about how modular synthesizers typically go down, but we usually use adapters like this, where you have a 16-pin for the power supply plug-in, and then you have a 10-pin for the synthesizer itself. Older stuff might want to use 5 volts, but typically we don't use it, which is why in the test setup I'm using 5 volts for the screen only. That'll utilize the 5-volt capabilities of the test setup nicely. But yeah, we don't use the 5 volts because we just make it from 12 volts. Interesting stream. Thank you. I spent a long time learning all this crap. And, you know, we'll get to other projects around here. I made a lot of progress with throwing waveforms in. Having the modularity of Eurorack systems means that we can really play with these amplifiers quickly. So it's nice to be able to throw circuits down very rapidly in this setup. I'm going to do orange wire is -12, so that's that bottom row of pins. Then the next 3 rows are ground. So ground, ground, ground. We'll make ground the black wire. This one's seen better days. And then +12, I always like to put that on the yellow wire. So that's the next in the 3 rows. So you basically skip every other row and you plug negative on stripe, ground, positive, it's basically the top 2 wires of the I2C connector. How do you know this, Bother? I've been doing this for too long. And so, all right, so we make sure to get ground, make sure I get this straight. Ground -12, oops, -12 on this pin. Ground is either of these 2, and then this one is +12. And it's all messed up over here in this center track because I set it up to be positive, ground, ground, negative, just as an easier way to remember how everything gets hooked up. So that will go to our VCO. Let me turn it off before I plug it in. I know how to position my wire. Theoretically, that shouldn't blow up. That's the run-in theory anyway. Do I have... No, that's frequency generator. Frequency generator going back to here. So if I unplug that, I could actually monitor what the output is. Or I can take a pin here, go to the ground, or go to the signal here, and then plug a green wire from our output to our input. And now that's on that one, and it's doing wave folding. So it's Crazy Go Madness nuts. Crazy Go Nuts on channel 3. That's our current waveform. It's kind of psycho. See if we can't put this into a mode where it works a little better. Now, there's something to be said for this design. It needs a little bit of work. It might need a little bit of work. Try to get into a better mode. Here's a triangle wave. A triangle, but we're also sending something else into it, so things are a little bit mad. It's going crazy. Okay, both switches up. We'll see if we can find a good mode. I still haven't programmed in the indicator light. I kind of had a bit of a block, a brain block. Oh, sorry. Yeah, scope. Madness! 10-volt madness! So this will be fine as another input. It's way above the 3 volts, and it gets us to kind of the maximum. So this will be our second channel. So now let's get to actually putting stuff down on this channel and mixing it in. So turn the power supply off for now. Yeah, that Hajiwo circuit is mad. It's a mad VCO. I love it. It makes some really crunchy noise on the output. I just need to be a better musician and actually use it. I haven't gotten down to actually like using these circuits for anything yet. I believe it was a red wire to get to the second one of these filters that we built the other day. Or maybe it was orange. So from there to where the yellow wire is plugged in. My dog got to play with the neighbors today. She got to run around with the neighbors. She had a great time. They were a little bit humpy for her. They are 2 little poodles that are incredibly high energy because they're puppies, and she has to constantly smack them down to get them to stop like being humpy. And so she got to play with them. She had a great time. She got a lot of exercise. She did zoomies, and now she's barking at the door because she sees other dogs outside. It's like, come on, just be satiated for a little while. You should be taking a big nap right now. But no, we've got to jump around and bark at the door. So the inputs of these are kind of like op amps, but a little bit different. Our input is coming from 15 and the corresponding pin 10, I believe. Yeah, it's pin 10. And then 11 and 13 are control, and 11 and 12 are outputs. No. 12 and 13. 13 and 12 are outputs, 11 and 14 are control. So we want to see what happens when I add in another signal, and we can just jump directly across to the other outputs and stuff. So if I take the 2 outputs and I want to bust them together into a mixer, all we need, I want to get bussing with this thing, all I need to do is put down a little clamp. Come on. Clamp. Yeah, I don't understand what all this talk about space between wires is. I don't, you know, it might make sense somewhere, but it just does not, it's not what we're thinking about right now. Control to control. So I want to go from 11 to 14. And our outputs are bus and our inputs are separate. All right, so yeah, that's all I need is 11 to 14. So 11, it's going to be yellow wire. It's always one of the most precious wires, which is the yellow wire, which allows me to jump to power stuff. So if I put 2 of these under control at the same time, under the same control, well, actually, you know what? First, we should take a look at what the outputs are separately. So what I'll do is I'll come over here and take my other potentiometer, and I'll get a jumper on that, just a little yumper, and I'll yump it from the other potentiometer control over to that control pin, and now we've made a mixer. That's all it took, was inputting another channel. So that mad signal that we saw over there, we should now be able to see the mix of the 2 on the blue channel. Okay. You know, like, we try to have nice things here, but then you just got to go and ruin it. There we go. There's the mix of the 2 on the blue channel. It's blah, 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 blah. It's kind of hard to reconcile what the mix between a slowly expanding sine wave and a mad triangle wave are, but here you go. And that tiny little bit of noise, that wibbling noise, that's the Sallen key filter. There might be a way to get rid of that, although you're not really going to detect it on your audio. the connections on the breadboard might be causing the noise. Okay, I can understand that. That's just what we got. So yeah, it's a little bit mad. Our notes are all kind of in the same place, but it does appear to be mixing the two. And we can adjust the volume of them. Let's see what we got. Let me go to channel 2, and let's put it above, get it up to 6 volts. Oh boy, that's saturating. So what's happening here is it's getting above 3.3 volts. Our input voltage is full Euro rack voltages. So I don't know what we can do about that. Turn up or down either one. Turn them both down to minimum. Yeah, I don't know what's going on there, because that is a strong signal. Also, our trigger level is having trouble with it. Oh, it's because we're triggering on the sine wave, and it's not really synced. The motion of the sine wave is not, the frequency of the sine wave is not synced, and as we move through the different frequencies, it's jarbling it all over the place. I would like it to be a little bit more definitive which signal I'm mixing in, though. See, that can go all the way into saturation at 4 volts. So that'll need a different resistor value on it, I guess. And the effect of the second signal is much lesser because it's a smaller signal. But I guess I can't turn this down enough because it's not getting to the right voltage levels. If it went to negative 600 millivolts, and I'll have to tune the resistor to make it do that. So now what happens if I want to control them both at the same time? Is that going to ruin the control that I have? Hard to tell what's even happening, though. I don't think so. It's kind of hard to tell, though. The reason that the volts are so jumpy is because this device is a Sallen-Key filter wave, and the Sallen-Key filter basically plays Flappy Bird with the signal. It has a very high frequency PWM coming out of it, and the PWM moves the voltage level, and then it discharges. So it moves the voltage and then it discharges, moves and discharges. That's why it's got that lumpy look to it. It's the path of a Flappy Bird. And so, you're not really going to detect that in audio stuff, really, that high frequency. I should probably put some kind of a filter capacitor on the output, though. I guess it lacks that. It could use that. But anyway, so that's the Sallen-Key filter. That thing is outputting a full 10 volts, whereas our waveform coming from here is 3. I mean, I could take the amplitude up to 5. That's as high as it goes. It goes plus minus 5 volts for this thing. So that's a slightly higher amplitude signal coming in, but that's the trigger channel. That's the channel that we are triggered to, channel 1. So if I change the trigger channel, and I go to channel 2, which is our output channel, that may stabilize things a little bit for that. But our changing audio coming in, our sine wave that's sweeping, is not going to change. Let's go to continuous wave mode, and let's lock that in to I wonder what that frequency is. What does it say it is? 3.6 megahertz? No, it should be like 1,000 hertz. What is a C key? Frequency on C2, it's saying it's 3.4 kilohertz. Let's try that. So frequency is 3.4, and then we'll hit the kilohertz button. That's a little better. It's still a little bit out of sync, but it's kind of jumbling around a little bit. 250 for middle C? Oh. Well, we're working in much higher frequencies, aren't we? If only I could sync them up. I think there is an input I could use one for an input sync, but that's okay. We don't need to totally view all of them at once. The middle channel is what we're looking for. I should probably move the yellow channel to be the output from the overall system, because that's a lot easier to see. But like, okay, if we concentrate on This is just our output from the two that are connected to one control. It gets weird if I move the control over. I can turn one down and up, and then the other one, this would be the, I think that's the triangle wave. Sine wave doesn't really appear to be adjusting at all. If I turn off the mad triangle wave. Okay, so that's actually a different, it's having a different effect. That one goes up to full. And then plug this one back in and remove, or remove the other one. Oh, yeah. See if we can get like a good looking signal out of this thing. It looks like the amps are doing a little bit of filtering for me. And they're smoothing out our OG signal, which looks like this. So I'm relying on this other circuit to kind of smooth it out. 250 double it per octave? Gotcha. I'm trying to get a signal that's not like insane, and most of the signals coming out of this thing are insane. I think a little bit of the software isn't quite working. This should be fine frequency adjust. I think the other one is filter adjust. What the hell's going on there? I think it's waveform folding. Yeah, see, there it is. This is wave folding. Bring this up a little bit. That might stabilize it. Okay, so that's the wibblitude. This is the longitude. And then I guess this is supposed to fold multiple times, but the range is so severely limited that it's not allowing for multiple folds. That's a software thing that I need to fix. This should be like a square wave, and then it starts to kind of fold in on itself as you increase it. But I should be able to adjust from a whisper to a shout. Oh, that ain't no whisper. So for some reason this... Okay, so the first problem, this adjustment is way too hot. Why? Why are you too hot? Is it a different value? $10K, $10K. Both are $10K. Why are you stupid? This one has resistor with a white stripe. Ah, okay. I mixed up the resistors. So turn the whole system off. Hopefully the VCO remembers where we left off. And I need to reverse these two. That makes sense. Makes a certain amount of sense. Yeah. The one that does the big reach needs to be that one. This one needs to be the other one. I see now the error of my ways. So this one with the stripe needs to do the big boy job. Let's do the big boy job, and that goes all the way over to here. Here, you guys, different camera that's a little bit less claustrophobic. All these little errors that you got to kind of correct in these setups. Hopefully there's enough lead here for me to bend it down. There is not. So one's 30, as close to 30 as I can get, and the other one's as close to 40 as I can get. So what value would that be? $330? No. $220? No. $75? No. $68? No. $56? No. $47? Too high. So, oh God, they're all missing. Wait a minute. I'm going to measure the other ones with the multimeter. I'm having a resistor crisis. I don't have all the resistors I should have. Let's see here. I can't believe I swapped those two. The other one's going to be fine. I can modify it just fine. It's just when a resistor's too short, you can't add lead to it. I have my doubts about 5.6K. Where's the one that I took out? Here it is. Again, this is why you might want to have a buffer op amp in there. Okay, that's a 39. And I know there's other 39s here. All of our resistor values are off by a little bit. We just have to kind of roll with that, which is why we're going to get close to the numbers that we want to see, but we're not going to see the exact numbers. And that won't be fixed until we get to having the actual headphone amplifier chip on hand. That's 100K. That's not useful to me. Some of these are 39s, though. This one has a stripe? No, it does not. That's like a 1K. This one. You're a 39, aren't you? Let's see. Truth be told. 39. Okay, perfect. So we'll take that, and we'll apply that to the measurements that we have from the caliper thing. Where's my YouTube comments? You guys are still there, right? I mean, I guess I do have the variable resistor, but I don't have, I need to use it right now. I got an OWO resistor. Don't need it right now. Better to be a compact design on the breadboard. All right, let's make sure these fold down properly. Get clippers. Make more of these little needle fine, finger puncturing clipped leads. And then get this into place. I'll measure and alter the other one. Just had to find the proper resistor. So the one we want is stripey on the bottom, and that goes from blue to the bottom pin. Where am I? Blue to the bottom pin. What the? It's like way too long. I measured it wrong. Son of a... Okay, hold on. We'll deal. From blue. Yeah, oh yeah, it's like way stretched. Okay, there's the proper distance. Alter these resistors to get them in. I mean, I guess there's something to be said for a solderless breadboard setup that's got all these wild components sticking out of it in every which way. Are you guys that sloppy when you put together your setups? I have to be super neat about it. I need it to be super neat and organized, because if I see clutter on my test setup, it just distracts me. I just get kind of mad. So I need to do all this stuff in order to make it like super nice. Everything fits perfectly, and you can see all the different facets of the circuit. And then some people build and it just looks like somebody stepped on a live wire. Like a whole party steps on a live wire. Everything's sticking out at weird jaunty angles. Same here. Yeah, I did, like, even this is bugging the hell out of me. I probably should have done like a little 90-degree bend in it, but that's, we can live with that. We can live with that. Oh wait, no, I don't. Wait a sec. No, this is bugging me because it's wrong. This goes here. Yes. Okay, and so the top one is the one that I pulled out. I got to make sure that the colors are the same. That would be this one. Ah, God, I hate it when it does that. Where did it go? To the cat dimension. Oh, there it is. Okay. Those are the same. Okay, so now I just measure that one, and I rebend this one. What I'm suspecting is going to happen is I'm going to need to make some kind of an op-amp circuit to buffer the voltage value into the mixer so that I can use it on 2 channels. Although, no, in their designs, they isolate the... each voltage is its own thing. And they talked in the data sheet about having individual voltages from like a buffer, but I don't know. I mean, I would hate to have to dedicate an op amp to each individual voltage, because that doubles the amount of op amps in my circuit. It's not good. We just don't have space for that sort of thing. Okay, so now we should be in the proper. Well, that didn't go in all the way. That didn't go in properly. When it fights you, oh man, this is so annoying. It's these little resistors. It's got like a little bend in it. It's a little bend. That little bend is all it takes for this thing to become obnoxious to work with. a little bend. Because it gets around the clip inside of its little hole, its little clippy hole. Okay, so now my levels should be the same. I messed up the resistors and it went way into the negatives. So if I put everything back, flip it around, turn on the power, we have a slightly different waveform, but I should be able to turn it up and it doesn't clip. There we go. So this is the appropriate use of this thing. Let's try to get like a traditional waveform in this instead of all these cursed, utterly cursed, folded waveforms. Turn the effects down as far as they go. It's the problem is my variable doesn't go far enough down. These are supposed to kind of fold in on themselves. In this mode, I just lowered the frequency. And up and down. Let's go to a different mode. Yeah, some of these have different modes depending on where these switches are. In this case, it's broken. I guess that particular one wasn't very kind and friendly. That's a decent enough square wave. We can base all over. Oh God, it's an inverting square wave. Okay, so yeah, that'll be good. Okay, so this is the output of our overall mixer going through these two knobs. And so if I turn this one up, oh, but it's not going in there yet. If I take the input and I plug it in, so there's the effect of a sine wave on top of a square wave. If I de-emphasize the square wave, it's going to bring that down to where eventually it kind of resembles a stable sine wave. Now, I can't turn them all the way down because this doesn't quite get to negative 600 millivolts. It's just a result of the resistors that I was able to find to take up those positions. But again, the effect of mixing these two channels with two separate volume knobs is that we have the ability to emphasize and de-emphasize the different waves. They basically turn up in your headphones and sound differently. The headphones are moving in sort of a, I don't know, we learned this in school. This is in college, how to put together two waves and make the output sensible. It's what a mixer's doing. So if I take the control away from the second amp and I give it to this, is that going to do the full range of it does? So I don't need additional hardware. See, what we tried to do was observe that volume level. We tried to observe that the voltage level going through this thing. And to be fair, wait a minute, does this? See, there it, I don't know if what I said was correct. How do we observe that the effect on both waves, maybe if I don't mix them and I look at the outputs individually. So what I'll do is I will take my jumper out of this thing. We'll turn off the circuit. Or no, I want to keep the circuit on because I don't want to, I think it saves all of my preferences, but I want to keep that square wave, that nice clean square wave. So I'm going to do this live. I'm going to take the tweezers and we'll pop open the jumper and we'll observe the signal level coming out of the amplifiers. So now this stage is only looking at that one wave, but we're controlling them both from the same signal. It appears as though it's not going as low as it can and it's not going as high as it can. So what if I take the second one off, which is this one? It goes both lower and higher now as a result. Oh, that's so annoying. Yeah, it has an effect. However many you're putting this thing through, it has an effect on your output signal. Which means I need more amplifiers on this in order to get the same effect out of the output. That is very annoying. So let's hook this back up. so that it's a mixer. I mean, it also means that I can have bias control pretty well figured out on this thing too, but you need individual voltages on each of these because they are represented by like a transistor. Down. Triangles. Oh, I'm gonna be sick. Oh, oh. It's a sort of a ghostly wooble that's added to it. With the proper resistance, by the way, I would be able to fully turn off the sine wave. But the sine wave is doing its low volume stuff to this thing. Okay, we've had a lot of good results today. We've had a lot of good results. We've had a lot of stuff going on here. One thing that we learned is to not listen to people's comments. No, one thing that we learned is the variable nature of these things. These getting all of the amplifier circuits correct and getting the right math is very difficult to do. And when you figure out kind of a little bit of a game plan, it helps to just switch over and do things physically. That way you can figure out what exactly is going on and what goes where. We've got a couple different circuit topologies to this whole thing, and we figured out that running voltage from one end to the other, or sorry, running our signals, I should say signals because they go from voltages to currents back to voltages. So we take it into these amplifiers, these voltage controlled amplifiers, we turn it into currents, and then we turn it back into voltages on the outset, and then it is then scaled. And we cannot use the non-inverting amplifier to attenuate our signal down to the appropriate level. I could use maybe like a voltage divider, but I don't like that. I don't think that's a great idea. And if we do have the two amplifiers, the inverting amplifiers like that, the output from there is the correct phase. It's got a little bit of phase delay, but it is in the correct orientation. So if your input and output are being pumped to speakers or something like that, you're not going to be like, this sounds funny. You want to make sure that things are in the same sort of positive and negative orientation. Now, we got it down to something close to a 6-volt signal using, was it 25K? It was whatever values we could find. It was 100K and something else. What was that? It was this one back here, 39. So apparently 39. 39K is apparently the appropriate thing, and that 1/4 needs to get out of there. Actually, we should just delete all of this and just do 39. I'll just write 39K on top of this, because our audio amplifier is going to be the next stage. 39K. For right and left biasing, I don't know what I'm supposed to do. Let's get rid of this. And if we're doing single-ended mode, then we just have another set of op amps. Then we run into the problem of how many op amps is it going to take in order to run this entire system. And it seems like it's a lot. It's going to be a lot of op amps. It's going to be a lot of op amps, unfortunately. And those op amps are going to be very difficult to get into the board. The board is very limited. My other question is, does this invert? Does this invert? We would ground reference that bottom pin and have a feedback on the other one. But what happens in single-ended mode? Single-ended input with a non-inverting gain. So non-inverting. So we would go into the plus, we'd have a 50 ohm resistor, then we have a 1K to ground and a 1K feedback, and then the typical 39.2 output. 39.2 is what they decided to have in the data sheets, so I'm probably going to try to find, 39-ish. It can be sort of in that range, and it should work for a variety of different amps, but I can put it in there, and then it'll be non-inverting. Question is, I mean, if I have 2 spare op amps, depending on the chips that I choose, I could possibly put an inverting amplifier on the signal and then use those differentials. Would there be a significant amount of delay, phase delay between the two? That would sort of not work well for me. I don't think that, maybe that wouldn't be the case. Why did they put VCC plus below VCC minus? This is mad. They're mad. Yeah, so, okay. So that's non-inverting. And that way you don't have a difference in phase between the ins and the outs. The other question I have, though, is if I put it into 2 stages, like the volume stage, like I have planned. Hold on, sorry. Is that then going to cause, because then maybe I'll have to do inverting, because it'll be original signal, inverted, non-inverted, inverted, and then non-inverted, inverted on the output here. So I guess that would work out. What we have right now, though, is our signal comes in, we go through one amplifier, it then mixes, so we got rid of this middle stage. So let's put back in the sort of middle dimming stage and see what that does with our signal in and out. So our signal in is right here on one channel. Signal in on the other channel is here. So that's what we're mixing. The voltage levels are not the same for everybody. Cool. Okay, so then we take that output and we route it to another channel of this mixer. So I'll take this, cut it off, and I'll put it over here. And I'll put it into channel 4, well, pin 4, which is this channel. And that's actually, wait, that's the output? Yeah, that's the output. We want it to go into the input, which will be pin 2. Input on pin 2. And I'll take, hold on, I gotta fix that wire over here. Double output going into the input over there. I should do this with the different kind of jumper. That's fine. Output and input there, and then we have a control signal that goes into pin 3. I don't know what to use for the control signal. We need like a 3 volt, you know, on a voltage divider on another one of these 10K pots. I guess I could just sacrifice one of the channels and just take this bottom one and put it all over to here to the control pin. And then our output is on pin 4, so I need another long wire that'll go over to our input op amp all the way over here. So that goes all the way to the input. Wait a minute, what did I, hold on a second. Oh yeah, because that output goes, yeah, on the 10K. Okay, yeah. So this one here is on the output, which is here. And oh, there's our signal. Well, there was our signal for just a second. Where did it go? Did it explode? Did I blow up the chip? Somebody gonna pop? What happened? Okay, blue is our output adjust. And there it is with that signal. So if I turn that down and I turn this up, well, that one's not as high voltage as the other one, so it doesn't have as much emphasis. But if we look at the square wave as our indicator, and I de-emphasize that there, we can see that our amplitude is the same. So we are not inverting. We got it just the same as the input. Okay, good to know. So there's no need for worrying about the amplitude from end to end on this. So that's non-inverting. Original signal comes in here, original signal comes out here, it gets inverted, it gets reverted. That's how that works. So it doesn't matter how many of these doodads I go through, it'll be just fine. It'll gonna be just fine. The other thing that I would worry about is if I can use, we have two, wait a minute. Do I need to have a buffer here, or do I need to have individual buffers for each one? That's sort of my other question. And that's probably in the data sheet. I probably just have to read it in the data sheet. That would be the TP, no, that's the wrong one. It's the V2164. Well, Why do I have multiple of this datasheet open? V216 for the cool audio, V2164. You see, like Veils and some of these other designs, the Hajiwo design, they were doing crazy stuff with the voltage level from the knob. Like we've got this big circuit that's doing stuff to this whole design, and I think what it's doing is it's making it into a logarithmic pot, but it also buffers stuff. I guess it's not really going into multiples. I don't know. Where are we? We're going into not that data sheet. There it is. Like cool audio data sheet. Cool audio. So yeah, let's see. What do they suggest? Cool audio. I just have to, every time I see it, I want to say it. This would be a typical mixer configuration where you have 4 separate channels and 4 separate outputs. So not mixer, sorry, a voltage-controlled amplifier, 4 and 4. But these have individual knobs. And no CVs. Low-cost 4-channel mixer, that looks familiar. And then, do they have any advice on the control signals? This is coming from a DAC, its own DAC, in order to control those. Weird. What the hell is this? That's a supply operation? I see. Well, we don't worry about that. We've got our dual supply. And then Cool Audio is done giving us advice. So the V2164, there's also an SSI and an SSM 2164. And from what I recall, the SSI 2164 has more fun datasheet knowledge to it. There's more circuits and stuff in here. And this is mostly the same operation as the other one. There's some caveats, some differences. So you got to be careful about the details. One of the data sheets was suggesting to me to run these things individually, these voltage controls individually. And or to buffer them. Signal path VCA control port. 0 to 5 volt linear control circuit. So -5 DC, what the heck? C in control inputs 0 to 5 volt. So 1 and 2, and they're linear. Oh God, that's confusing. Signal path VCA control port. So they're basically what they're telling you how to do is like the Euro rack mixing kind of stuff that you do with like, oh, you can take a CV in, there's also a knob, and it's that sort of thing. Looks very complicated. Temperature compensated, oh boy. Temperature compensated exponential voltage to current converter. Why would I want that? This seems too complicated. And then here they've got 12 volts, and there's the temperature compensator. I see. And they're taking a divide of 339 ohms to 100 ohms. The capacitor's in there for, I think, to clean it up. And the TVL431A is a temperature compensating device of some type. So you've got between 840 ohms and the rest of the circuit going to ground. Scaled the upper resistor? That's weird. Okay, anyway. They have all the equations down here. I'm sure they explain it better than I would ever be able to. So I don't understand. I mean, FC, in this case, coming in and adjusting all of these simultaneously, because we're kind of trying to do that, right? With our left and our right channels. But we definitely see a difference between our voltage level between the, when we hook up more channels to it. Economical low frequency oscillator. It's not really that economical because of this chip. All right, I guess I'm gonna have to look it up a little bit more. Tomorrow, I don't know, maybe we'll do like an AutoCAD stream tomorrow. Maybe we'll do that. And we'll do something that's not as mathy as what we've been doing. I've been trying to avoid math. I've been trying to avoid doing a complete datasheet spelunking fest. But I am running out. I kind of ran out of stuff. We tested everything we wanted to. We had a really good result with everything. We've discovered that we can indeed mix the signals as they thought. It's just our control needs a slight revision, and adding more op amps is not going to be great for me. I'm going to be real with you, dog. That's not really going to work out very well. I could put in some of those little, what is it, 5-pin transistor sized op amps, because if I need 3, I could put 1 near each knob, but that's very it's very restrictive to the space that we're dealing with right now. So let's, I mean, I can take this into Fusion and we can put the theoretical number of what is going on? We can put in the theoretical number of op amps into this thing. What we've discovered so far is that we are going to need 2 on the output, and that's it if we don't put a buffer in. So we need 4. So that's 1 quad op amp. So 1 quad op amp in order to run this entire circuit in single-ended mode without the headphone amp chip in there yet. I have yet to put it into Fusion because we have yet to breadboard it. I want to breadboard it before I dedicate an entire design to a part. Let's open up our design. This is unfortunately not sponsored at the moment, but maybe tomorrow we can do something that's not circuits. I can do like desk design, and we'll do that like a physical design in Fusion 360. The reason that they gave me this software on a sponsorship was to show off the electronic stuff, but I'm gonna end up doing some non-electronic stuff with their software. All right, so in order to get these expressed in the 3D model, we need to work through the schematic first. So I have a TL072. I'm just going to go ahead and delete this thing. So let's delete this thing. Goodbye. Deleted. Deleted. I'm using right-click to get to delete. You can use the delete tool. The delete tool stays up, so you have to hit escape after using the delete tool to make sure you don't accidentally click on something and destroy your design. I've had this happen before at Eagle, because delete is not just deleting something, it's getting rid of the reference throughout the entire, throughout all the stages of the software. And so delete is its own tool. You can't just, well, you can hit the delete key. I guess that works too. But like, it's a tool that you're in. So you got to make sure that you exit that delete tool. It'll bite you. So we got rid of the 2 op amps. What we're going to do is we're going to go to the parts over here. That's the wrong thing. Go to the place component tool. And we're going to go to specifically my components, well, actually chips managed. In chips managed, I have TL074. And you can obviously swap for a different op amp, but the TL074 is the 16-pin op amp, or no, 14 or 16? 2, 3, 6, 9, 12, 14-pin. The 14-pin op amp. I'm going to go for an SO14. There is a smaller type. I don't know how that'll work. Let's just start with the SO, because the SO is a whole lot less torturous to put down on the board. So I've selected that from the drop-down. I double-click on the part, and then we're in the component placing tool. I don't need these to be in a specific spot, but I'm just going to put down 1, 2, 3, and 4. And what the software does is it tells you that it's the A, B, C, and D of the component. And that's in how you design the part. A, B, C, and D will reference to specific op amps on specific pins. We don't know which ones we want to use yet because we don't know the overall layout. We're still doing the sizing and locations and stuff. So can we use this part in our final design? Let's take a look at the 2D layout. Bonk. That's just that tool in the upper left-hand corner. Can we do this? So there's our TL074, and it has been unceremoniously dumped beyond the edges of our board, and it is on the top layer, which is where all of our connectors are. Now, I probably could have done this design the other way around so that our connector, because our connectors are in a fixed location at this point. I still can do that. I still can drop everything down to the bottom layer and then work from the red layer being the top, or I can change my views. I can change my layer view in order to be from the bottom. It basically just mirrors. Now, if I grab the part, click and hold, I can center click, and that moves it to the bottom layer. You can see all the pins, all the pads become blue. Where will this op amp fit? That's a heck of a question. Well, it's not going to fit in normal spacing there. So if I do alt spacing, will it fit? Due to the way the design rules are set up currently, this thing will not cooperate because it's just too big. And there's only one location that I could really get away with putting it, and that's right under the potentiometer. But it will not play ball, something with the way the IC is made. That 8-pin one I got to fit, and I'm not sure what I did in order to fit it. I might have edited some design rules in order to get it to fit. Let's try the smaller one. So I'm going to go back to the 2D design. Actually, I wonder if I can do this. I can right-click and do package, and then I can just click on TSOP. Oops. See, I'm still in the package reassignment tool. I have to escape. Now I can actually click on something and move it around. Now, technically that fits. Technically it fits with the smaller thing. These are very annoying to solder. This would be all of the op amps that I would need on this board, or I could maybe go to a couple TL07-2s. Because if these are all the op amps, these are basically for the output. These are going to be down here with the output. And then I need to have like components around this thing. Resistors and such. So that would actually be fairly difficult to build. Depending on how small I could make the surrounding circuitry, you need like 2 resistors per amp. So I could have a right side and a left side drive, op amp drive on this thing. 45 degrees, that would be kind of cool. That might actually work. Can we do that? Hold on, properties on this thing. And the rotation, 270. Let's just put 45 in there and see what happens. Oh my God, it's cursed. I don't usually work with them like this. It can only fit in one. Oh my God. I have to use alt spacing, and it only likes certain. Whoa. Why did it fit and then not? Weird. I would like it to be a little bit further up, but I mean, yeah, that could maybe free up a little bit of space for some resistors and stuff in sort of this area down here and this area up here. That would be fascinating to get to work. Not wide enough for the board. Well, I don't know how many I'd be able to fit in down here. That's one strategy on the TL07-4. I don't know. We'll have to figure out whether or not we can make this stuff work. I mean, the other strategy would be to, well, no, there's no other strategy. It's either this or the SO14, and the SO14 like barely fits in there. And if I'm going to have clipping indicators, that would mean probably another one of these. And then the other question is, yeah, it's all due to the clearance rules. I need to put in the not PCB way. I need to put in the JLC PCB rules into Fusion. I've got sort of rudimentary rule systems in there right now. But yeah, so yeah, food for thought indeed. We will come back to this, and just to see it cursed, let's see the cursed 3D 45-degree chip. I mean, looking at like the Synthro, as much as I hate to reference Synthrotech, that guy's got some fucking ridiculous baggage. Anyway, I hate to reference them, but Synthrotech fit a lot of stuff onto a flat PCB, exactly like what we're doing. There was a lot of stuff on that board, so. This is supposed to be a quick project. Quick project. All right, so what it did is it just re-rendered the board, and since we're not moving any of these plugs, although I should probably move them to the bottom layer of the board, instead we've got the cursed 45-degree chip right here, which I kind of like. I kind of like this just because of how cursed it is. I don't know why it wouldn't allow this to slide up a little bit, though, and center. So we got to look at some of those rules and make sure that they're kind of properly stated in the whole thing. But I could do, like, everything in here at 45-degree angles. The thing is, I can't get the Cool Audio chip in this size. I can't. So what we're actually going to need is, let me go back to here. It's going pretty quickly for a bother project. Ouch. That hurts me. You've hurt me. These do go slow, though. So yeah, you're not wrong. Okay, so let's put in two, we'll just put in two, you know, whatever's, two TL074s, because they're just in SO14. They're the same size. Is that right? Yeah, they are. They're the same size. So where's my TL074? TL074, and we're doing it in this size. I'm going to just put these outside of the drawing. 1, 2, 3, 4, and then 1, 2, 3, 4. So this is the amount of stuff that I got to fit on the back of this board. All this stuff has me thinking about the differences between the analog and digital grounds for video cards with RAM DACs. I don't know, man. We're doing a fairly analog design with this. I mean, I could. I gotta mess with the rules. I gotta mess with the rules. I don't know how I got this to work before, but the only place that I would be able to fit the 14-pin voltage-controlled amplifiers is on the exact opposite end of the knob. And then that doesn't even account for how power's getting in. I need somewhere on this board, I need a 5-pin through-hole header, which I'll be able to do by cutting it flush. I'll do a flush mount header on that. But yeah, then I need to route signals between these two. One of them will be, the individual LRs are all going to have to go to one of these. And then the other one is going to be the output from this one going to this one. And that'll be the volume control for this knob down here. Time for a 4-layer board. I'm hoping to avoid it. Listen, I've seen people do a lot with this form factor. Not just from 2HP. I'm looking for whoever's showing me the bottom of the 2-panel Euro rack mixer. No, not shopping. Is it 1 HP? Wait a minute. What are we talking about here? It'd be 1 panel? Yeah, when I was searching this stuff up, there were some designs that really made a lot out of the very small amount of space in one singular rack panel. I mean, you can do a lot of lazy mixing. You can do a lot of stuff where you just throw all the channels together and say, good luck. That's not what I'm doing here. That's not what I want to do here. Yell at Julian and tell him his design requirements are stupid. Yeah, I mean, it would be nice if I could use 2 panels like this size. I could definitely fit in a lot of extra features in that, but I have not pulled the ripcord on this thing yet. I've not pulled the eject button. We have 2 strategies to get around any sort of additional space needs. Right now, it looks vaguely possible, which is why it's so tempting. It looks sort of vaguely possible that we could maybe fit this thing in. And if I need additional op amps, maybe I could put in the op amps that are the size of transistors, and I have room underneath the connectors in order to do so. But if I'm backed further into a corner, if I'm actually not really going to fit any of this stuff, you know, crazy tricks aside, maybe I've got 2 strategies. Not maybe. I have 2 strategies. One is to do flush headers that are right angle headers, and then I have a flat board of about 30 millimeters by 100 millimeters. That would mean I need 2 circuit boards to do this, and I would have a pinout in between the boards, and I would have to position the headers so that they're just right, and it's a lot of flush cutting and stuff like that. That could work. I could actually make that work really well, and I could make it shorter than 100 millimeters so that the power plug can plug in at a right angle as well. That's a decent strategy. The other strategy is to do a couple of the standoffs like we were looking at before. A couple of these guys just at 90 degrees, and then that'll give me an entire 100 millimeter board without any of the through-hole stuff sticking through it. Yoink, 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 yoink. It is a mess. This circuit is a mess, but I'm not terrified of small SMD soldering, but I do feel like this is unreasonably tight. This is why it's Julian's absurd mixer. But again, like, I don't want to look up Synthrotech. I gotta find that design though. If I look up, I don't know where I found, you know, we got plenty of pictures of the 2HP stuff. So 2HP sells these very small Eurorack modules. They're all in this same design, this one single little blade, so that you can get the maximum amount of modular synthesizer in your modular synthesizer. And if we look at the home page, they have this picture right here. And so we can see all the different strategies that they use in order to pack so much technology into such tiny little boards. And typically with a more complicated design, of course, they are using the op amps that are the smallest ones, the ones that Mutable Instruments uses. That's probably a microcontroller up top. And then they have a right angle connector that connects power in order to connect board to board, to board to board to board. What they have are right angle headers that go to surface mount pins, I think. But in my case, I don't want to buy that. I want to get that. I don't like those because they break off really easily. So what I would do is solder in the headers and then super duper flush cut them, or cut the headers and then solder them so that solder doesn't poke out, and then you've got a flat pad on the top and you can just install this stuff over top of it. And then I think there's one or two on here that actually have like two boards that are in parallel. Maybe not. No, they're not. They don't show anything like that. They just love their headers. They love their right angle headers. And it gives you that little tiny bit of space below it to run your whole circuit. So those are the strategies, and we're trying to figure out whether or not we can actually get away with, ooh, naughty. Naughty, naughty, 2HP. What are you doing with this? What's going on down here? Did you guys mess up? Did you mess up on your circuit board design? Did you have to correct it? Anyway, so that, yeah, we have strategies, we have places we could go with this. I got to figure a bunch of stuff out. Making this as tiny as possible is sort of the challenge of this. So we're going to try to fit it all in one board. I'm going to have to pull out all the stops, but in order to get there, I need to put the cheapest board service rules into the CAD program so that everything can line up. We have a little bit more circuit work to do because I need to figure out what it's going to take in order to mix all of the outputs of these knobs or get them to multiple channels. It's some kind of a resistor calculation or something. It should be voltage controlled, but it's the internal whatever. Anyway, we're not going to use our brains tomorrow because I think we've smeared our brains all over this project to the point where we don't have any left and it's kind of a little too thin over everything, our brain schmear. So what we're going to do, unless I have a change of heart, we're going to work on my desk. I'm trying to redesign. I've been doing this for years, but I really want to redesign my actual working desk so that it has two 19-inch rack compatible panels on either end. It'd basically be like two rack panels holding up the middle, and then in the middle, I can, since it'll be made out of the 20mm frame rail, I can do something weird like attach a steering wheel. I'm hoping maybe that can happen. We'll see if it's going to be two rack things or one on one side. And Julian was offering me that before, but I'm like, no, I'm going to make it myself because I got an expensive chop saw and I've got an aluminum blade in the chop saw, so I'm able to cut 20/20 rail or 80/20 rail if I want to make it, you know, like this thing with the big rail. That's big rail. It's like 2 inches, I think. No, I think that's millimeter standard. We can measure it when we get to it, but we'll work on that tomorrow. Good Lord, the sun is down and the cold air is leaking in, so I'm going to call it here. We're going to come back tomorrow, same bat time, same bat channel, and we'll work on that then. Until then, here is some social media stuff. We've all been moving to Blue Sky because it's not filled with assholes. There are assholes on Blue Sky, but if you look around enough, you can find blocking. Like, it's like one link that you click in order to block everybody. If you're new to Blue Sky and you click on my profile, scroll all the way down to the bottom. You'll see a list of people to follow. Click on that follow thing, you'll find hundreds of makers. And so that'll branch you out into other stuff like what we do here. yeah, thank you guys for joining, and I'll see you guys tomorrow. That's all I got. Oh yeah, let's wait. Hold on. Let's see if like don't add on or anybody. I haven't been raiding a lot lately, just because I almost immediately jumped to the outside. Helldivers too. No way. Paleontologizing, of course, is on as another one of these smart boy Twitch things, smart people Twitch things. Call of Duty. When did I follow that person? All right, so I don't see a lot of Macosphere people doing their thing. I was thinking of raiding Davies, but he's playing Helldivers too. I don't know if my audience is going to want to play Helldivers too. But check out Davies if you guys want. Davies runs a great stream. It's not shouty or anything like that, and he plays games. He has fun. But I'm gonna go walk the dog in this winter wonderland that we've got going on outside, and pray for rain. Have a good one, everybody.